हॅलो गाईस, किती म्हणता? लेट झालंय 10 मिनिटं. हेड सम वर्क. ऐकू आता? इज इट क्लिअर, ऑडिबल अँड क्लिअर अँड visible also? Please let me know. Yes. ओके. खूप किती किती डिस्कस करपाचे आसा बिकॉज दिस पर्टिक्युलर चॅप्टर्स आर व्हेरी स्कोरिंग चॅप्टर्स. सो त्या खातीर हांवें मातशें हांगा एक कितें म्हणटाय का PDF फ्लो तयार केला. PDF फ्लो म्हटल्यार मागीर हांव खंय हांगा ते खंयचेय PDF ओपन करपा जायना, सारकें सिस्टमॅटीक ओपन जावपा जाय लायनीन. हय, इम्पॉर्टंटूच सांगतलो बाबा. स्पोर्ट, येस, आय विल टेल एन इम्पॉर्टंट ओनली. आणि बेगीन ते बेगीन सोंपया बिकॉज आय हॅव टू गो फॉर ब्रेकिंग माय फास्ट ऑल्सो. नाल्यार हांगाच करचें पडटलें उदक पिवन म्हाका. Okay. We'll wait for more 5 minutes. We'll start at exactly 5:15. Okay, exactly 5:15 we'll start. I'll try to finish it by 6:15 if possible. तुमकां सांगतलो कशें कितें शिकपाचें सारकें करपाचें आयज बसोन. And I'll be giving you the predicted list. आनी एक काडला मातशी तीच आसा, बट द थिंग इज इट इज हॅव्हिंग मोर प्रिसायज क्वेश्चन्स. सो ते क्वेश्चन फक्त तुमी याद करपाचे, थियरी. मोदी सरकार म्हाका 30+ पडना जाल्यार सरचे फिल्डिंग सेट कर बाबा. तू बी कर आता फिल्डिंग सेट. माझे पयलींच केला खूप जाणांनी. तू बी कर. येस, गुड इव्हनिंग, स्मूथ गिविंग. थियरी लर्न केल्या पुरो. येस, थियरी ओनली विल बी डिस्कसिंग मोस्टली. आणि ते VBT आसा ते तुमकां दाखयतलो मातशें कशें कितें आसता ते. एंड द क्वेश्चन्स ऑफ VBT आय विल बी टेलिंग यू. We will be starting exactly at 5:15. What is the time now? 5:13. We are having 2 minutes. So मातशे बेगीन तुम्ही लाईक करा मरे. लाईक केली ना टार्गेट दिवपा जाय तुमकां. आनी computer science, when you're having computer science, let me just share the links. Okay, so let us start now. I've posted the links and okay. So yeah, we'll be starting with our remaining last, which are the most crucial chapters, that is biomolecules, DNF block and coordination compounds. Okay, so आज अभी किती करूया, we will go in a flow with the how we have made particular types of things. It is very important that you know these things. कितें बिकॉज जर तुम्ही सारखे याद करून ना एटलीस्ट मातशें वाचल्यार सुद्दां तुमकां मागीर एग्जामीक बरोवपाक इजी पडटलें तें. सो फर्स्ट इज which one? Okay, first is this particular PDF. Just I will go very fast in this and I will just let you know. तुम्ही पहिले असतले हू इज इन द कोर्स दे हॅव ऑलरेडी सीन दीज PDFs. सो आय विल जस्ट गो फटाफट. तुम्ही बेगीन बेगीन लाईक करीत राहात. ओके, आणि पळयत राहात. लाईक म्हाका जाय आयज 200 लाईक जाय म्हाका आयज. कितेंय करून 200 जाय. Okay, so basically this particular PDF we are having specifically designed. I have designed this specifically for the questions which I'll be expecting in your paper. Another ek PDF asa wherein I have put detailed questions, and that questions also you have to study. So let us just see that, just for getting the overview, because थोडी भुरगी आसा तांकां खबर सुद्धा ना की हो चॅप्टर आसा म्हणून. असता तशें असता. Okay, I was from that category, so I was not having like idea about ki thode chapters kide asa ki na maka khabar nasle. So biomolecules, okay, this is there in your chemistry. It is also there in biology we asle biomolecules, but it is in chemistry also. In chemistry we are having some specified questions which are coming for biomolecules. Very predictable sarke abhyas karpa jay. So first thing, the questions what I am expecting, it is related to peptide bond. Okay, so formation of COH of one amino acid and NH2 of another. Water molecule is eliminated, that is the condensation reaction happening. So CONH linkage, that is the amide bond. Now this is the amide bond and that is the peptide linkage. So basically questions you can expect is what is a peptide linkage. Yeah, question expect karta what is a peptide bond. एक म्हाका खातीर, सो ते हांव एक्सपेक्ट करता. नेक्स्ट इज आय एम एक्सपेक्टिंग व्हेरी हाय प्रोबॅबिलिटी, जे तुमी आतां शिकले आसतलीत तुमी, दॅट इज द डिनेचुरेशन ऑफ proteins. What is the meaning of denaturation of protein? It is loss of biological activity. Best कितें फालतूपणा बरोवप ना, जे जाय तेच बरोवप, then you will get marks bro. Okay, that is loss of biological activity of words तुमचे मेन्शन जावपा जाय थंय. Secondary and tertiary structures are disturbed, अशे वर्ड्स मेन्शन जावपा जाय. Primary structures remains intact, हे तुम्ही मेन्शन करू शकता की primary structures remain intact but secondary and tertiary structure ते booch marta. That is denaturation of proteins. Okay, causes kide asa for this? They might ask you what are the causes for denaturation of proteins. The causes are heat, like चड हीट जाली जाल्यार denaturation protein जाता. Denaturation protein कितें, आता तुमकां example सांगता. ताती जाणा ताती. Okay, you eat egg. Now egg आमी कितें बेश्टे अशे कितें म्हणटा, रॉ खाल्ल्यार इट इज लिक्विड. नो, इट इज लिक्विड. रॉ कोण खायना चडशे, पण कोण खाल्ल्या जाल्यार it is liquid, like it is not actually liquid but semi liquid, semi solid sort of. But when you heat it, तुम्ही boil करता तेका, when you are boiling it, then the tati becomes hard. ताती असता हार्ड जाता. आणि पयलीं ते ट्रान्सपरंट कशे आशिल्ले, पण आता कितें जाता, जे एग व्हाईट असता पळय, that egg white becomes opaque. Okay, milky color जाता. Why? Because the primary proteins आशिल्ले थंय, but sorry, basically they were the tertiary, secondary and tertiary proteins आशिल्ले, they got denatured म्हटल्यार त्यांची बूच मारली, ब्रेक झाले, ते डिस्टर्ब झाले, स्ट्रक्चर्स अनकॉइल्ड जाता. ते पयलीं कॉइल्ड असता, अशे कॉइल्ड असता प्रोटीन्स, but when you apply heat they become uncoiling. Okay, so that is the uncoiling of the protein structure. When it becomes, you get the denaturation, म्हटल्यार coagulate जाता protein. Coagulate म्हटल्यार घट जाता. That is the basic idea how you have to write this particular question, which I'm sure short expecting in your paper. Okay, next another question I'm expecting for 2 marks if it is coming. 2 marks, that is starch versus cellulose. Okay, starch versus cellulose. Sir, how much our class depends how much it is getting by. 69 likes mare, 69, nice. Okay, make it more. So starch versus cellulose. Starch, that is alpha glucose polymer, helical, digestible, energy storage कितें तेजे हे आसा. Cellulose कितें असता, it is beta glucose polymer, straight chain, not digestible. आणि तेजे structural role कितें आसा, म्हटल्यार starch कितें रोल प्ले करता, and basically sorry, starch रोल कितें आसा. Starch plays the energy storage so role play करता, आणि cellulose असता तो structural असता. Starch can be digestible, cellulose cannot be digestible. Starch is made up of alpha glucose polymer and cellulose is made up of beta glucose polymer. Both are polysaccharides but are having different functions based on these qualities. I am expecting this question also tomorrow for 2 marks. Okay, differentiate. So then again one more question we are expecting, that is the DNA versus RNA. ओके, डीएनए वर्सेस आरएनए कितें आसा ते तुमी सगळे सारखे बरोवपाचे. हांवें ऑलरेडी दिला, हांव चड काय उलयना हेचे बद्दल. ओके, बट इट इज व्हेरी हायली प्रेडिक्टेबल दॅट डीएनए वर्सेस आरएनए टू कम इन युअर पेपर. ओके, 2 मार्क्स म्हटल्यार एक 2 पॉइंट बरोवप. डीएनए चे 2 पॉइंट्स आणि आरएनए चे 2 पॉइंट्स. बेश्टे पॉयंट म्हटल्यार एकच लायन बरोवप ना, बरें मातशें मोगान बरयात. ओके, सो दॅट तुमकां टिचर मार्क्स घालपा जाय. बेश्टे ते रोमाट करपाचें ना आनी इम्पॉर्टंट keywords असता पळय तेका अंडरलायन करा. इफ यू आर नॉट अंडरलायनिंग द इम्पॉर्टंट keywords, Goa Board does not give you marks. They will give you marks, but अंडरलायन करून कीवर्ड्स तेजे काम मातशें इजी जाता कोणाचे एग्जामिनरचे. सो एग्जामिनर येता आनी पळयता ओ माय गॉड नायस म्हणटा आनी डायरेक्ट मागीर मार्क्स घालता. ओके, so yeah, next is we are having the glucose structure, intermolecular hemiacetal formation. That also I'll be showing you in the next PDF. fast अशें दाखयतलो तुमकां कितें आसा, कितें शिकपा जाय. So intramolecular hemiacetal formation, so it is basically the cyclic structure of ग्लुकोज. ओके, दोन तरेचे जाता, आयझोमेरिझम जाता थंय. सो दोन तरेचे जाता, ते आयझोमर्स आमी बरोवप, डी ग्लुकोज आनी डी ग्लुकोज आनी एल ग्लुकोज, ते सगळे हांव तुमकां दाखयतलो की कितें करपाचें, सारके अभ्यास करून वचपाचें. ओके, डायग्राम्स. Vitamins, we are having fat soluble and water soluble. Very important. MCQ. Okay, MCQ for vitamins. Either the question will come which vitamins are water soluble, you have to take the correct one, and they will give you a vitamin that vitamin ditle A ditle, is it water soluble, blah 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 blah. Okay, and what is fat soluble, water soluble, tasha vitamins ditle, or they will ask you the specific question regarding that which particular vitamin plays a particular role. The vitamin A किती करता, vitamin D किती करता, vitamin E किती करता, vitamin K किती करता, vitamin B किती, vitamin C किती. आणि note down one more important question I'm telling you, maybe hanga asa ki na म्हाका खबर ना, but I am having a very good gut feeling of it. That is, what is the scientific name of vitamin C? Okay, हे मातशें तुमी करा. ओके, हांव सांगिना कितें, तुम्ही मातशे अभ्यास करपा जाय न्ही, सगळे लायन दिले म्हटल्यार दॅट इज नॉट इफेक्टिव्ह टीचिंग. ओके, essential versus non-essential amino acids. Essential versus non-essential amino acids is also a very very important topic. Now कित्याक तुमकां सांगता, हांव तुमकां सांगू शकता, प्रेडिक्ट करून सांगू शकता की हो क्वेश्चन येतलो, बट द थिंग इज वाय आय एम टेलिंग यू टू स्टडी these many important topics is that these are very helpful in your later on stages. So how concise dita, but you have to study what I'm telling you. That is essential and non-essential amino acids. It is why essential, eka essential kidak manta, why it is. Ata pay दोन condition येतले examine, दोन condition on this question. If it is coming, two conditions are coming for the answer. One answer you have to write the answer based on their origin. ओके, ओरिजिन म्हटल्यार एसेन्शियल अमायनो एसिड्स कशे असता, ते ओरिजिनेट जाता खंयच्यान, म्हटल्यार आमकां घेवपा जाय की घेवपा नाका, बेस्ड ऑन द डायट. ओके, सेकंडली इट विल नॉट डायट, सॉरी, बेस्ड ऑन ओरिजिन. सेकंड क्वेश्चन व्हाट कॅन बी आस्क्ड इज दॅट एसेन्शियल आणि नॉन एसेन्शियल अमायनो एसिड्सचे डायटचे बद्दल विचारतले ते, की डायटान कितें असता, खंयचे नासता. आणि बेस्ड ऑन डायट, इफ यू आर बेसिकली हॅव्हिंग अ अमायनो एसिड in your own body, then you don't have to take it from outside, because already your body is synthesizing it. So it's okay, that is the non essential, because तुझ्या बॉडी आसा ऑलरेडी. आणि जे अमायनो एसिड तुझ्या बॉडीक जाय, जे तुझी बॉडी तयार करू शकना, तेका मी म्हणटा एसेन्शियल अमायनो एसिड्स. एंड एसेन्शियल अमायनो एसिड्स हॅज टू बी टेकन फ्रॉम दी फूड सोर्स. म्हटलं असे बी घेवप ना, इट इज फ्रॉम द फूड सोर्स. ओके, नेक्स्ट डिटेल्ड रिजनिंग अबाउट दॅट. ओके, फायन. पेप्टाइड बॉन्ड डिटेल्ड रिजनिंग जे हांवें तुमकां सांगला ऑलरेडी तेच आसा. सो इट इज लायक इन द पीडीएफ सगळे डिटेल्ड रिजन केला की कशे पेप्टाइड बॉन्ड जाता, कितें तरेके तेजे क्वेश्चन येऊ शकता. मागीर बेस्ड ऑन द एप्लिकेटिव्ह सॉर्ट ऑफ क्वेश्चन दॅट कॅन बी आस्क्ड, इज द बॉन्ड फॉर्म इज एन अमाइड लिंकेज कॉल्ड एज अ पेप्टाइड लिंकेज. सो अशें बी येता की the bond formed in amide linkage called as a peptide bond. So if the bond form as a amide linkage, it is called as dash. कितलेशे तुमकां येतले हायड्रोजन बॉन्ड, हे बॉन्ड, ते बॉन्ड, ते बॉन्ड, but you have to mention it as peptide bond. Okay, next, repeating peptide bonds are called as dashed. Okay, these are basically called as the polypeptides. So repeat jata, peptide, 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 खूप peptide. Polypeptide, poly means खूप, many, पेप्टाइड, पॉलीपेप्टाइड. ओके, इजी, व्हेरी इजी. डिनेचुरेशन सांगलें तुमकां, सांगलें हें आतां परत डिस्कस करिना. स्टार्ट विथ सेल्युलोज तुमकां सांगलें. देन आय टोल्ड यू व्हॉट इज डीएनए वर्सेस आरएनए. सामकें डिटेलान आसा हांगा, मातशें डीएनए आनी आरएनएचे पळय, इतले पॉयंट्स आसा. हेच पॉयंट्स घालप रे बाबा, जाले. हेच पॉयंट्स येले जाल्यार. ओके, हे पॉईंट घातल्याला रॉंग जावपाची शक्यत ना. देन ग्लुकोज स्ट्रक्चर, कसलो ग्लुकोज स्ट्रक्चर आसा, दॅट स्ट्रक्चर आय विल बी शोईंग यू इन द नेक्स्ट पीडीएफ. ओके, स्ट्रक्चर. सो हे सगळे आसा, व्हायटामिन्स कितें आसा, सॉल्युबल, नॉट स्टोर्ड, एक्सेसिव्ह विटामिन बी, सगळे ते दिला. एसेन्शियल वर्सेस नॉन एसेन्शियल, एवरीथिंग इज गिवन. देन वी आर हॅव्हिंग व्हेरी हाय प्रोबॅबिलिटी क्वेश्चन्स फॉर द DNF ब्लॉक. आता खुबशे भुरग्यांक हे चॅप्टर खबर आसताच. तांकां खबर आसता म्हटल्यार आसता. कित्याक खबर आसता? बिकॉज DNF ब्लॉकान चडशे थियरीच आसा आनी चडशे भुरगे कितें करता, पास जावपा खातीर थियरी सब्जेक्ट्स स्टडीज करता आनी टीचर ऑल्सो सजेस्ट देम that study this particular chapter. So I'm telling you what things to study in this particular chapter. So if you're talking about the DNF block, we are having variable oxidation state. Variable oxidation state म्हटल्यार कितें की DNF ब्लॉकचे जे एलिमेंट्स असता त्यांचे जे ऑक्सिडेशन स्टेट्स असता ते खूप असता, वेरी करता म्हटल्यार एकच एलिमेंट आसा. फॉर एक्झाम्पल कॉपर इज अ डी ब्लॉक एलिमेंट, सो इट विल शो टू ऑक्सिडेशन स्टेट्स. Usually कितें असता, if you're talking about chlorine is showing only one oxidation state, that is the reduction state we are talking, but still. But then if you are talking about other element, it is the hydrogen actually shows two oxidation state, depends on कितें म्हणटा conditions, but usually we take it as H plus. Then if you're talking about lithium, then lithium usually shows only the basically one oxidation state, that is the lithium plus. Okay, but if you're talking about copper, then copper shows +1 and +2. ते कितें दाखयता? That is the question. Why copper shows two different oxidation states? First thing, it is from the D block element, and as it is from the D block element, it will show variable oxidation states because of the participation of D and S orbital in the bond formation. Outer orbital is S orbital and D orbital. So if you're talking about copper, we are talking about the 4s and the 3D. So 4s and 3D both will be taking part in the bond formation. If both are taking part in the bond formation, then both can lose electron, both can gain electrons. If both can lose electrons, then both can show different types of oxidation states. Okay, so that is the question we are talking about. Okay, next we are having why transition elements are colored. Wow, very favorite question of mine. My favorite question. Why transition elements are colored? This is my favorite question. So why it is? Because presence of partially filled d orbitals, d and d electronic transition occur, absorption of visible light show complementary color. आता पळय हेच क्वेश्चनाक रिलेटेड आसा. वयलो क्वेश्चन आसा पळय, वेरिएबल ताळो सुकता, वेरिएबल ऑक्सिडेशन स्टेट आसा पळय, वेरिएबल ऑक्सिडेशन स्टेट चेरूच हो क्वेश्चन फ्रेम्ड आसा. मीन्स इट इज रिलेटेड. वाय? बिकॉज सी, आता when is basically any color being seen? Color केन्ना दिसता आमकां? It is basically a physics related question की color केन्ना दिसता. If we coming under the physics चे applied chemistry येता, then we are going into it as about the electron which is absorbing the light. Okay, so electron कितें करता? Electron एकटो आसा न्ही, बेसिकली चड एकटो आसा, अनपॅड आसा. पॅड असल्यार तेजें लग्न जालें, आतां तो तेज्या लायफान कलर काय ना. कपल जाले की त्यांचे वेगळे कलर असता, पण भायर तेका मागीर कलर दाखोवपा मेळना. सो इट इज सेम थिंग. इफ इट इज अलोन, इफ इट इज एकटो आसा, जाल्यार तो खूब कलर कितें म्हणटा तेका एक्सप्लोर करूंक शकता बेस्ड ऑन द लायट ऑफ वेवलेंथ ऑफ द लायट एब्सॉर्ब. एकटो असला जाल्यार इलेक्ट्रॉन. पूण इलेक्ट्रॉनाचें लग्न जालें जाल्यार एक ऑर्बिटल असता, इन दॅट 2 इलेक्ट्रॉन असता, अशे वयर सकयल असता. हेंचें म्हटल्यार लग्न जालें. आतां लग्न जालें म्हटल्यार आतां एका कलर दाखोवपा मेळना. ओके, तेजे कलर फक्त हेच जाणा बायल तेजे कितें ते. सो तशेंच ते मागीर दॅट इज बिकॉज दॅट अनपॅड इलेक्ट्रॉन्स आसता पळय, ते चड कलर्स दाखयता, मीन्स कलर्स दाखयता, आनी पॅड इलेक्ट्रॉन आसा, ऑर्बिटल फिल्ड आसा, कंप्लिटली फिल्ड आसा, इट इज नॉट शोईंग एनी कलर. सो इट इदर द ऑर्बिटल इज कंप्लिटली एम्प्टी, जाल्यार इलेक्ट्रॉनांना कलर कोणाक दाखयतलो? इलेक्ट्रॉनांना. ऑर द ऑर्बिटल इज कंप्लिटली फिल्ड, जाल्यार बी आमकां कितें आतां कलर दाखोवपा मेळना. बट द ऑर्बिटल इज इनकम्प्लिटली फिल्ड, then they are showing its own different types of colors. आणि केन्ना इनकम्प्लिटली फिल्ड असता? जेन्ना ते वेरिएबल ऑक्सिडेशन स्टेट्स असता. ओके, पहिली 2 इलेक्ट्रॉन ना, मागीर 3 इलेक्ट्रॉन ना, मागीर 4 इलेक्ट्रॉन ना. सो वेरिएबल ऑक्सिडेशन स्टेट विल शो वेरिएबल different types of colors depending on with whom it is bonding and at what wavelength the light is being absorbed. Okay, कळ्ळें मरे, अशें असता. ओके, नेक्स्ट वी आर हॅव्हिंग द वाय ट्रान्झिशन एलिमेंट्स आर कलर्ड. ते जालें, तुमकां सांगलें हांवें. एब्झॉर्प्शन ऑफ विजिबल लायट तुमकां सांगलें सगळें. आनी इट इज लायक इनकम्प्लीट आसा, फुल्ली एम्प्टी आसा ऑर्बिटल, देन इट विल शो नो कलर. आणि फुल्ली भरलेली असा ऑर्बिटल, देन ऑल्सो इट विल शो नो कलर. फुल ना, फुल म्हणटा म्हटल्यार पांच पांच डी डी आता ऑर्बिटल आसा, डी ऑर्बिट आसा, मागीर ते डी ऑर्बिटान 5 ऑर्बिटल्स असता, ते 5 ऑर्बिटल जर भरलेले आसा, then it will show no color. So that is the basic idea. Magnetic behavior, magnetic movement, he upload kela. This is a very a very rare question to be asked, but I have put in case it is being asked, and I have put for the practice also, so you can just practice the numericals what I have given. Very rare it is, but still you can just practice it. So magnetic moment, basically the magnetic moment ki of the spins of the electrons, they as a concept. So nu is equal to root of n into n plus 2 into bm. Okay, that is the magnetic moment we are doing. So now if you are doing the detailed stepwise solutions, so formula used, if you are looking, then you have to understand what is the basic formula of this. This particular formula is nu is equal to mu is equal to root of n into n plus 2 bm, where mu is magnetic moment, that is the Bohr magneton, and n is the number of unpaired electrons. That's it. इतले तुमका खबर असपा जाय कितले moment असा. So if you are looking for the particular एकूच तुमका solution दाखयता, then you can just revise all the particular solutions. So if you are looking over here, atomic number of ion, that is 26. Step 1 is electronic configuration. We are writing the electronic configuration, and basically if they are telling us that it is Fe3 plus, आमका calculate करपा जाय. Fe3 plus चे magnetic moment calculate करता, तेन्ना तुमका electronic configuration अशें बरोवचें पडटा, because you have to lose this particular 2 electrons and 1 electron from here. So it becomes argon 3d5. Now if you are having argon 3d5, then the step 2 is number of unpaired electrons. How many number of unpaired electrons are there? If you are looking at the orbital of this particular thing, the 3d5 orbital, it is having 5 1 1 1 1 1. 5 electrons. So these are all number unpaired electrons. 5 unpaired electrons we are getting. And step 3 is apply the formula. You have to just apply the formula. Nu is equal to root of 5 unpaired electrons into 5 unpaired electrons plus 2. And you are getting root of 35. And root of 35, you are getting it as 5.92 bm. Bm is the Bohr's magneton, is the unit of the magnetic moment. Okay, इतलेच आणि काय ना, same thing, everything we are having. So we are having, you have to write the final answer like this: magnetic moment of Fe3 plus is equal to 5.92 Bohr magneton. Okay, मागे तसेच हे असा boy, same thing, 25 ले हांगा तेंच्यानी सांगला Mn2 plus. So Mn2 plus म्हटलं हे 4s गेलो, हे उरले मागे कितले असा अनपेड इलेक्ट्रॉन्स, डी ऑर्बिटल असा 5 म्हटलं 5 एक 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 करून 5 इलेक्ट्रॉन असतले. आता कोणाक खबर ना, ते दाखयता मातशे थोडे खबर बी नसतले. सो this is the d orbital, आम्ही काढला 1 2 3 आणि हे 4, हे d orbital. This is the 3d orbital we are talking. If you are talking about 3d orbital, then we are having 1 2 3 4 5 आणि हांगा असले आमचे 4s orbital. This 4s orbital was having 2 electrons. आता हे जे Mn2 plus म्हणून सांगला तेंच्यानी, Mn2 plus. So Mn2 plus म्हटल्यार 2 इलेक्ट्रॉन लॉस झाले, म्हटल्यार हो बाबू गेलो म्हटल्यार हे उरले. आता हे सगळे अनपॅड आसा, आता तुम्ही म्हणटले अशें कित्याक घातला, वांगडा कित्याक घालूंक ना? दॅट इज अकॉर्डिंग टू अ प्रिंसिपल. विच प्रिंसिपल? टेल मी इन द चॅट. विच प्रिंसिपल? एकले घालता ते आमी 11th स्टँडर्ड. Come on, guys. Tell me, begin. According to which principle? एक घालपा जाय इलेक्ट्रॉन. फर्स्ट शिफ्ट पुढे एक मागीर आमकां भरपा जाय. विच अफबाव प्रिंसिपल. ओके, व्हेरी गुड. अफबाव प्रिंसिपल आणि मागीर आसता ते पावलीज एक्सक्लुजन प्रिंसिपल आसा, मागीर हंड्स रूल आसा. सगळे तुमकां याद दवरपा जाय इफ यू आर अपियरिंग फॉर नीट एक्झाम. जेई तर तुमचे एक जाले सेशन, दुसरे आसा. सो हे सगळे बारीक बारीक याद दवरपा जाय, बिकॉज क्वेश्चन्स कम लायक दीस ओनली एप्लिकेटिव्ह. ओके, नेक्स्ट वी आर मुव्हिंग टुवर्ड्स, जाले हे सगळे जाले अशेंच आसा. तुमकां घातला प्रॅक्टीस करपा खातीर, बिकॉज इतुरले येवंक शकता क्वेश्चन इफ जर ते घालपा सोदता जाल्यार. ओके, मागीर सेम थिंग्स. ओके, सेम थिंग, very very easy. Okay, next question, which I am also expecting and you are also expecting, that is Lanthanoid contraction. Lanthanoid contraction म्हटल्यार कितें ते तुमकां डायरेक्ट हांगा बरयल्लें आसा. अशेंच तुमकां पॉइंट वायजान बरोवप, आपल्या ओन वर्ड्सांनी पॉइंट वायजान बरोवप. Okay, you don't have to write a paragraph, you have to write in point wise. That is gradual decrease in atomic and ionic size from lanthanum to lutatum. So reason is poor shielding effect. हे विचारले तुमका, what is the reason basically for lanthanoid contraction? It is the poor shielding effect of the 4f electrons. Now what is the meaning of shielding effect? ते तुमका खबर असपा जाय. Poor shielding effect म्हटल्यार कितें आसता? शील्ड म्हटल्यार कितें? आमी प्रोटेक्शन करता, शील्ड. सो भितरले जे ऑर्बिटल्स आसता पळय, 4f असता, तेजे भायर आनी इलेक्ट्रॉन्स असता, तेंका मरे शील्ड करपा जाय फ्रॉम द न्यूक्लियर चार्ज. सो न्यूक्लियर चार्ज कितें? सगळ्यांक ओडपा सोदतलो इलेक्ट्रॉन्स आपले लागीं, बट जे भायले जे 4f इलेक्ट्रॉन्स आसा पळय ते ऍक्ट एज दे शूड ऍक्ट एज अ शिल्ड, बट दे आर नॉट ऍक्टिंग एज अ शिल्ड. ते म्हणटा की ना तू तेका ओडटा, ते माझ्या फाटल्यान ना तेका ओड. ते असे ओपन रावता, हा ओडा तुम्ही, आमकां फरक पडना म्हणून. सो द न्यूक्लियर चार्ज गोज बियॉन्ड द 4f ऑर्बिटल आणि भायले सुद्धा इलेक्ट्रॉन्स कितें जाता, ओडून येता. सो दॅट इज कॉल्ड एज द शील्ड, पुअर शिल्डिंग इफेक्ट. शिल्डिंग इफेक्ट म्हटल्यार प्रोटेक्शन करप, पूण ते प्रोटेक्शन करिना म्हणून भायले सगळे इलेक्ट्रॉन्स बी ओडून येता टू द न्यूक्लियर चार्ज अँड द atomic size shrink जाता, and that is called as Lanthanoid contraction. Okay, so yeah, हे तुम्ही करा Lanthanoid contraction. I'm not discussing more about it because we are just discussing the important things. So Lanthanoid is the important thing. Next, difference between lanthanoids and actinoids, a very rare question to ask, but a very important question also. So we have to study it. की lanthanoid किती असा 4f filling mostly and points आन दिला. ते तुम्ही आपले own words आन बरोवू शकता. कसे बरोवू शकता? You can write that in lanthanoids the 4f filling happens first. 4f filling, 4f orbital filling happens. And if you're talking about next point, you can write that it is mostly having the +3 oxidation state in lanthanoids, and the lanthanoids are less reactive. 3 points बरवले तुम्ही. सारखे बरे 3 पॉइंट्स इन द डिफरन्शिएट. एक साइडीन 3 बरयले, ह्या साइडीन आनी 3 बरय. इथून कितें जाता, 5f इलेक्ट्रॉन फिल जाता. हांगा व्हेरिएबल ऑक्सिडेशन स्टेट असता, +3 म्हणून व्हेरिएबल असता, आणि हांगा हे हायली रेडिओ ऍक्टिव्ह असता. सो हे 3 पॉइंट्स तुम्ही बरयल्यार जाले, बूम. ओके, देन why transition element form complex compounds? Why they form complex compounds? First thing, it is having a small size. Small size मतलब कोणी येऊन दादागिरी करतलो. Okay, so कोणी येता म्हणता ये मरे मारुति वैन में आ जा, चल किडनैप करेंगे, like that it is. Okay, small size it is. So it is not like that. Okay, sorry, I am really sorry. Small size म्हटल्यार कितें, सायंटिफिकली स्मॉल सायज म्हटल्यार तेका अकोमोडेट करपाक, बॉन्ड करपा खातीर ते जे रेडियस असता पळय, आयोनिक रेडियस, एटॉमिक रेडियस, इट इज व्हेरी गुड टू फॉर्म अ बॉन्ड अँड अ स्टेबल बॉन्ड. So that is why it is happening. Okay, ते मारुति बिरुति बरोबर नाका किडनॅप करपाचे. Okay, next, high charge density. It is having a very high charge because high charge density कित्याक, साइज कमी आसा आणि भितर चार्ज, त्या एरियान चार्ज खूप आसा. म्हटल्यार एरिया पळय, एरिया स्प्रेड जाली. लिंबू सोडा तुम्ही घेता, लिंबू सोडान साखर इल्लीच घातली आणि लिंबू सोडा फुल व्हडलो ग्लास केला, साखर कमी घातला जाल्यार गोड टेस्ट आसा तो इट इज नॉट व्हेरी इफेक्टिव्ह. बट तेच तुम्ही एक बारीक ग्लास घेता आणि तितून तितली साखर घालता जाल्यार कितें जातलें, कमी जागो आसा म्हळ्यार ते साखराचे टेस्ट कितें जाता, चड एनहान्स जाता. सो हांगा ऑर्बिटल सायज, द एटॉमिक सायज बारीक आसा आणि चार्ज चड आसा, सो इट इज व्हेरी concentrated. So that's why it is called as high charge density. And we are having the presence of vacant d orbitals. Vacant d orbital asa कित्याक, because variable oxidation state, तेंका जाय आपले इलेक्ट्रॉन सोडटा आणि vacant d orbitals असता. सो ऑर्बिटल जर वेकंट आसा जाल्यार दुसरो इलेक्ट्रॉन, दुसरे कंपाउंडातलो इलेक्ट्रॉन येता आणि आपण म्हणटा की आपण तुका सॅटिस्फाय करू शकता बाय गिविंग द इलेक्ट्रॉन्स, विल यू मॅरी मी? Okay, so he's like, yeah, why not? Okay, so it is like the presence of vacant d orbitals. Next, having catalytic activity. This also a question I'm expecting about the catalytic activity. Okay, variable oxidation state asta. Why? Question is why the transition elements are showing catalytic activity. You have seen, no, that we're using palladium, platinum, palladium. Jana marate, in organic chemistry we are using it. So it is showing a catalytic activity. Matlab it is acting as a catalyst, means speeding up the reaction. So catalytic activity कित्याक असता, because it is having variable oxidation state, first point. Secondly, it is forming intermediate complexes. So whenever we are using transition element, then transition element helps to make a stable intermediate product which can be made into a final product. So it becomes a very stable process. डायरेक्ट करपाक गेले जाल्यार खूप लेंदी, खूप एनर्जी कंज्युमिंग आसता, खूप टाइम लागता. सो इफ यू आर मेकिंग एन इंटरमिडिएट, सो पयली एक स्टेबल जालो, मागीर तो मातसो सुशेग घेता, मागीर तो फायनल प्रोडक्टान कन्वर्ट जाता. एंड इट इज बीइंग हॅपनिंग बिकॉज ऑफ द ट्रान्झिशन elements, because they are forming the intermediate complex. Is very important, yaad dora. Then it is having surface adsorption. Now what is the meaning of adsorption? तुमका ते चॅप्टर डिलीट केला surface chemistry, but I will just tell you what is the meaning of adsorption. Absorption म्हटल्यार स्पॉन्ज पळयात तुम्ही, स्पॉन्ज असता आमच्या घरा मम्मी आयदनां घासता ती स्पॉन्ज असता. दॅट स्पॉन्ज एब्झॉर्ब्स वॉटर, म्हटल्यार तेजे भितर वॉटर असता, तो भरलेलो असता पोर्सांनी, इंटरस्टिशियल स्पेसिसान भरलेलो असता. बट इफ यू आर टॉकिंग अबाउट अ स्पॉन्ज, आणि मागीर कितें जाता सांग, जर आमच्या टेबलाचेर कडी पडला, कडीन उदक असतले आणि कडीन कितें असतले, कडीन कोकोनट हे असतले. ओके, नाव दॅट पर्टिक्युलर कोकोनट जे असता पळय, जे कडीचे असता, ते स्पॉन्ज घेऊन जर तू तेजेर पुसपाक वयता पळय, देन द वॉटर इज गेटिंग एब्झॉर्ब्ड. बट जे खोबरे असता पळय, दॅट इज गेटिंग स्टिक ऑन द सरफेस. इट इज नॉट गोइंग इनसाइड, इट इज ऑन द सरफेस, बट इट इज जॉईंट. दॅट इज कॉल्ड एज एड्झॉर्प्शन ऑन द सरफेस. आणि कडीचे उदक गेले भितर, तेका म्हणटा एब्झॉर्प्शन. ओके, So that is the meaning of surface adsorption. Who does the surface adsorption? The कितें म्हणटा transition elements and surface adsorption जाता अशें surfaceाचेर, so it increases the surface area for reaction. So त्या खातीर आसा. ओके, आतां चड तुमकां डिटेलान शिकोवपाक म्हाका time ना, because I want to teach, I like to teach this. Then we are having the moderate possibility questions. Interstitial come very moderate. Okay, I am not having alloys question. You can study that why transition elements or not transition element. Basically transition element करताच रे, but specific question comes for the lanthanoid series, कि why lanthanoid series make good alloys. Okay, and it is very hard to separate them. And the specific question last time मी सांगलेलं तुमकां हांवें, zirconium and hafnium. हे क्वेश्चन ZR and HF, zirconium and hafnium, तेजेर क्वेश्चन चडशे येता, because it is very important and very interesting question to Goa board. ओके, आता पळया आता घालतले काय माझे लायफ बी पळयत बसले आसतले. So then what is actinoid contraction also you can study. It is related to lanthanoid contraction only, but you have to just flat out just point about the 4F and 5F. So like that, and the variable oxidation state. That is the difference we have done already. So magnetic moment, strong prediction, variable oxidation state, colored transition elements, lanthanoid, lanthanoid versus actinoids, difference. Okay, exam strategy ते तुम्ही पळयात मागीर किती strategy आसा ती. Then we are having the predictions for coordination compound. Exactly तुमकां कितें अभ्यास करपा जाय, because सगळी भुरगीं आतां लायफाक रावची ना. Some kids will be looking at this and they will be going and studying, which is very good. I don't mind, because later on you can watch the video. So important definitions कितें आसा, definition जे आमकां अभ्यास करपा जाय, it is the what is the meaning of coordination compound, what is the meaning of ligand, how many types of ligands are there, ते सुद्दां तुमकां अभ्यास करपा जाय. कोऑर्डिनेशन नंबर म्हटल्यार कितें तुमकां खबर आसपा जाय की व्हॉट इज कोऑर्डिनेशन नंबर आनी कशें आमी आयडेंटिफाय करू शकता कोऑर्डिनेशन नंबर. सो व्हेन वील बी डुईंग दॅट पर्टिक्युलर VBT नो, तेन्ना तुमकां हांव सांगतलो की व्हॉट इज कोऑर्डिनेशन नंबर, ऑर एल्स यू मायट बी नोईंग इट. What is the meaning of chilate? Okay, chilate or chillate or chillat, chilli kide. But what is the meaning of this? That you should know, because this is a very strong question to be coming in your paper tomorrow. Okay, what is a chilate and what are chillating ligands? सारख्या. Then what is the meaning of central metal ion and oxidation state? Okay. हा, माय गॉड, ताळा सुकता मरे. तुम्ही लाईक करीना, लाईक करा बेगीन. 103 आसा, येता वयता टाइमपास करता, लाईक करून चला. गेल्या जाता पण लाईक करून चला. IUPAC nomenclature examples are here. आणि मागीर एक सामके बेस्ट PDF घातला, ते दाखयतलो हांगा तुमकां. असले PDF घातला की फ्रॉम दॅट ओनली नो क्वेश्चन्स येतले, फ्रॉम दॅट ओनली. आता सांगतो तुमकां, फ्रॉम दॅट ओनली द क्वेश्चन विल कम. सो IUPAC nomenclature, हांगा तो nomenclature दिला, that is CONH3 6Cl3. So what is the meaning of this? Hexaamine cobalt 3 chloride. आता हांव हे एक्सप्लेन करता, मागीर तुम्ही समजून घ्या की कशें आमी करतात ते, because this is a revision, I cannot go very much in detail. So just see here how IUPAC nomenclature in coordination compound is being done. डायरेक्ट करपाचें, चड रोमाट घेवपाचें ना. तुमकां पयलीं खबर आसपाक जाय की नांव खंयच्यान स्टार्ट करपाचें. नांव आमकां स्टार्ट करपाक जाय फ्रॉम हियर, दॅट इज माय लिगँड. ओके, दॅट इज अ इलेक्ट्रॉन डोनेटिंग ग्रुप. हांगाच्यान स्टार्ट करपाक जाय. त्या उपरांत म्हाका मागीर हांगा सेंट्रल मेटला कडेन येवंक जाय, सेंट्रल मेटल. एंड लास्ट आय विल नेम माय आयन और anion, I would say. Okay, the negative charge वालो. आता हेका जर हांव सेपरेट करता, आता हेका घेता हांव, ओके, हेका घेता आणि हांगा उडयता पळय, सेपरेट करता. सो आय एम टेकिंग दिस, सो आय एम रायटिंग हियर कोबाल्ट एंड आय एम रायटिंग हियर NH3. कितले फावटी आसा? 6 फावटी आसा. हे करता, हेका सेपरेट केले म्हटल्यार हांगा कितें जालें, आणि हेका सेपरेट केले. क्लोरीन, कितले क्लोरीन? 3 क्लोरीन आसा. 3 क्लोरीन हांगा घेतले, Cl3, meaning it will be having -3 charge. कितले आसतले? एक क्लोरीनाक एक -1, so Cl3 म्हटल्यार it is having -3 charge. Now this particular cobalt NH3, आता हांगा -3 काढले, हांगा चार्ज नशिल्ले न्ही. Here there was no charge, म्हटल्यार हांगा +3 चार्ज आसा. टोटल कितलो आसा? टोटल इज +3. आता म्हाका खबर आसपाक जाय, हो कोण? हो अमोनिया मरे. अमोनिया कडेन चार्जूच नसता, इट इज न्यूट्रल. सो हेजे कडेन जर चार्ज ना जाल्यार हो डायरेक्टली विल बी अप्लायड टू दिस cobalt. So that is the oxidation state of cobalt, +3. Okay, now cobalt is having +3, meaning आम्ही त्याचे नाव कोबाल्टूच बरयता. ते तुमकां दाखयता मागीर कशें ते. सो नाव बरयतना फर्स्ट कोणाचें सांगलेलें हांवें, फर्स्ट यू रायट द नेम ऑफ अमोनिया. कितले आसा? 6 आसा. सो आमी 6 बरयना, आमी बरयता हेक्सा अमाइन. मागीर आमी हेजें नाव बरयता कोबाल्ट. आता हे कित्याक केल्ले? बिकॉज आय वॉन्ट टू रायट द ऑक्सिडेशन स्टेट. सो कोबाल्ट 3 अशें रोमनान घालप, कोबाल्ट, आणि मागीर कितें आसा? क्लोरीन आसा. कितले फावटी? 3 फावटी. ते आमी हांगा बरयना, फक्त आमी बरयता क्लोराइड. That is how you name coordination compounds. Okay, Next, what we are having? We are having the next one is here. Okay. Now, if you're looking over here, then you can just see over here. Ami ata konak name ditli ata. Now you tell me what name we can say. First thing is we have to name the electron donating parts. First one is the main ligand. Main ligand कोण असा आमचं water. That is the main ligand. Second कोण असा electron donating. It is this particular chlorine. Okay. And third मागीर असेच follow करपाचे. Ligands केले मागीर follow the third one, that is the central metal, and then you write the fourth one. आता चार नाव आमकां हांगा घालपाक जाय. आयडेंटिफाय केले आमी. हो पयलो कित्याक हो 4 फावटी आसा. हो दुसरो because of 2 फावटी, because this is also negative, so it will donate the electrons chlorine. And then this is my central metal atom or central metal atom, and this chlorine is my anion. So आता हेच सिक्वेन्सान आमी नाव दिवपाचें तांकां. कितले फावटी आसा उदक? उदक आसा 4 फावटी. So it is written as tetra. आणि उदका खातीर आमी water बरयना, we write aqua. Okay. Tetra, aqua or aqua, whatever you want to say. Tetra, aqua. Then कितले फावटी chlorine असा? It is 2 times, but chlorine is inside the coordination sphere, so we don't write it as chlorine, we write it as chlorido. किती बरयता आमी तेका? Chlorido बरयता. कितले फावटी असा? 2 फावटी. So डाय chlorido. मागीर कोण असा? सेंट्रल मेटल आता कोण आमचो? क्रोमियम. आता हे 3 कशे आहा ते कशे कळटले आमकां? दॅट इज अ व्हेरी इम्पॉर्टंट थिंग, बिकॉज हांगा कितें आसा? हियर वी आर हॅव्हिंग क्लोरीन, सो वी हॅव टू अगेन सेपरेट इट. अगेन आमकां कितें करपा जाय? सेपरेट करपा जाय. सो सेपरेट इट. ओके. क्रोमियम, वॉटर 4 फावटी आणि मागीर क्लोरीन 2 फावटी. हेका सेपरेट केले आणि हे एकूच क्लोरीन तेका भायर काडले. सो हेका भायर काडले जाल्यार इट इज ओनली वन टाइम, नो? सो हांगा टोटल चार्ज कितलो आसतलो? इट विल बी +1 total charge. Total charge is +1 over here. So now how you know that it is +1? If I know that water charge कितले असता? It is 0. Water is having 0. Now this particular chlorine 2 असा म्हटल्यार it is -1 plus -1. So chlorine कितले असा? Total it is -2. So chlorine is having -2. This is having 0. आमका total charge कितले जाय? आमका total charge जाय +1. So I have to take this into consideration, no? So I will take it chromium as x. Chromium x घ्या. हे उदकाक मागीर हांगा घालता ते आमी उदकाक आमी 0 घालया आणि मागीर प्लस करता ते आमी -2 घालया इक्वल्स टू +1 म्हणून घालया. Okay. Now you have to just substitute x +0 हे मायनस झाले. So here this becomes +0 -2. So it is become -2 is equal to +1. Now we are having this x is equal to -2 आणि ते थंय वतले. So it becomes +1 +2. So x becomes +3. +3 मेळ. So तेंच्यानी किती बरयला? क्रोमियम 3 आणि मागीर लास्ट तेजे क्लोराइड. Like this you have to solve the nomenclature. Full detail on waspak time now. Okay guys, next. PDF is on the app. Okay, let me just share the link. कोणाक जाय they can go and they can take that particular PDF. कळ्ळें रे? कोणाक कळोंक ना ते सारखे नोट कराय कितें केला ते फॉर द सेकंड क्वेश्चन. हाका बेंची आपुणूच हालता. कोण तरी क्लास अटेंड करता दिसता. कोणाक बॅकलॉग पडलो लास्ट लायफान. सर हे 3 चॅप्टरचे तुवें सांगला तेच केल्यार फूल पडटले. फूल कशे पडटले? हितून फूल हितून फूल पडोवंक शकता. ओके, हितून. नेक्स्ट कितें आसा? सर माझी 82% आयलेले आनी जीईसी एडमिशन मेळटलें न्हू. व्हेरी कॅटेगरी कितें आसा? जनरल, ओबीसी, ईडब्ल्यूएस, that depends on that. Okay. Because 82% and if you are from general category, very rare to get into the elite departments like mechanical, electronics, electrical. Civil magir civil you can get, but that also depends. ST mare ST zala gautle. Okay, what are you targeting for? You are targeting for what? Civil, mechanical, electronics, IT kide. that depends. Okay, yeah, that we will have a discussion later on. uh, okay, types of isomerism चे रे full एक pdf असा, that also pdf I'm uploading now. आता दाखयतलो मागीर upload करतलो because upload करपाक time मेळोंक ना. I was making it. So types of isomerism कितले तरेचे isomerism आसा आमच्याकडे आसा हांगा first geometrical isomerism, आमच्याकडे आसा optical isomerism. Okay, geometrical isomerism, and then we are having optical isomerism. These two isomerisms are coming under stereo isomerism. आणि मागीर आमच्याकडे आणि 4 आयझोमेरिझम असतात आम्ही डिस्कस केले. आयोनायझेशन आयझोमेरिझम, लिंकेज आयझोमेरिझम, कोऑर्डिनेशन आयझोमेरिझम, and there was one more thing that is called as hydrate or solvate isomerism. They are already घातला in that PDF. Okay, so that is important. Next is crystal field theory. Crystal field theory की जे तुमचे दोन पर्टिक्युलर डायग्राम्स असतात ते डायग्राम्स तुम्ही याद करत चढ डिटेलान त्याचे काय एक्सप्लेन करपाना. टेक्स्टबुकान आसा तोच डायग्राम मातशे एक 3-4 फावटी प्रॅक्टिस करा. That is having for the T2G lower energy level and it is having for the EG higher energy level. दोन splittings आसा for the octahedral complex ते तुम्ही स्टडी करपा जाय. Okay. Magnetic moment तुमका सांगले आहे strong and weak field ligands. Strong and weak field ligands in that you are having the कितें म्हणटा examples आसा थोडे जे examples माझे already PDF आन आसा examples of that. So खंयचे strong field ligands असता आणि खंयचे weak field ligands असता, so that you can identify and why it is important to know which is the strong field ligand and which is the weak field ligand. It is because whenever you are getting a question for the drawing for the VBT in the octahedral complex, त्यांना दोन तरेचे complex form जाता. It is the inner complex and it is the outer complex. Okay, so inner complex केन्ना form जाता and outer केन्ना जाता, that depends on the weak field and the strong field ligands. Okay, so ते सुद्धा we will discussing in the next PDF. Okay, color of the coordination compound सांगले तुमका. Then why it happens, because again it is happening because of the DD transition. Why? Because the metals are used, no, these are from the D block elements. So DD transition असता थंय. आता D block element जर कलर दाखयता जाल्यार ते कोणा फॉर्म जातले कंपाउंड करतले. दीज आर द कॉल्ड एज कोऑर्डिनेशन कंपाउंड्स. आणि कोऑर्डिनेशन कंपाउंड बी कलर्स आमकां वेगळे वेगळे दाखयता बिकॉज ऑफ द DD transition. That same it is the relating answer. Okay, next we are having the Werner's theory. Werner's theory चे postulates याद करून चला. Werner's theories postulates याद करून चला. 2 मार्का खातीर क्वेश्चन येवपाची प्रोबॅबिलिटी आसा. 4 तरी postulate 4 नाल्यार 5 तरी postulates बरोवपा जाय. ओके, नेक्स्ट मोस्ट लायकली क्वेश्चन. सो CFT splitting diagram. तो डायग्राम याद करा. 2 डायग्राम्स आसा ते सांगता तशे. Okay, if they're telling you to draw the diagram for the EG of the higher energy, if they're telling for you the T2G for the lower energy, so ते कसे सांगता तसे डायग्राम फक्त तुम्ही सारखे डायग्राम काढपाचे आणि लेबल करपाचे. ओके, दॅट इज आय हॅव टू एक्सप्लेन इट. एक्झाम स्ट्रॅटेजी बिटेजी ते सोडून घाला, मागीर ते तुमकां घातला ऑलरेडी. कोऑर्डिनेशन कंपाउंड लिगँड मागीर ओके, दीज आर द डेफिनेशन्स तुमकां स्टडी करपाक घातला इन द PDF. सो हे तुम्ही करू शकता. मागीर हांव चड काय हांव उलयना. IUPAC nomenclature. nomenclature आनी एक PDF आसा, हांगा बेश्टे तुमकां nomenclature करून दाखयले ऑलरेडी. सो आय एम नॉट explaining all these nomenclatures. These are for your own practice. Okay, हांव 2 दाखयतलो, तुम्ही 10 सॉल्व करपा जाय. then is when you get good marks. Okay, सो मागीर आयझोमेरिझम हा घातला. वेगवेगळ्या तरेचे आयझोमेरिझम आसा. आयझोमेरिझम एक्झाम्पल आसा, CFT आसा, हाय एनर्जी लो एनर्जी आसा. मागीर इट इज डिपेंडिंग ऑन द डेल्टा नॉट ऑल्सो. डेल्टा नॉट हा ते ओ अशें येले वयर. It is delta naught. So if delta naught is large, pairing occurs. If delta naught is small, no pairing occurs in the CFT, crystal field theory of the octahedral complexes. Magnetic moment सांगलं तुमका. Then strong and weak field ligands. हांगा cause of pairing of electrons. Example cyanide. Okay, weak field ligands हांगा दिला पळय 2-3 examples. मागीर color, मागीर Werner's theory and secondary valency. Okay, which valency determines the basically कितें म्हणटा geometry. So it is the secondary valencies which determines the geometry. Okay, so this is done, this is done, this is done. Okay, this particular PDF is directly towards the biomolecule PDF directly. Okay, biomolecule PDF मातशे overview करूया in that particular PDF. Biomolecule PDF, please pay attention to that. Biomolecule काय आसा, biomolecule हा. सो एक थोडे क्वेश्चन्स आसा दॅट यू कॅन जस्ट कित्याक सांगता तुमकां, सो दॅट तुमचे तकलेन मातशें एक विज्युअली ते पडपा जाय. दॅट्स वाय आय एम एक्सप्लेनिंग दिस पर्टिक्युलर PDF. टोटल कितले 7-8 PDF बेगीन करूया. So next is this is basically a worksheet what I made, and in this what you can see is different types of questions which are having the particular answer and how the answer has to be written. So what are essential and non-essential amino acid? Give two examples of each. So that is the first question. The first question: the amino acid that can be made in our body, therefore we cannot require them in our diet, are called as non-essential amino acids. The amino acids which are not synthesized in our body are to be supplied to our diet, are called as essential amino acids. Okay, so here question asa. Second question: what are the two types of photosynthesis in green plants? Give a basic structure of photosynthesis. Blah, blah, blah. Basic structure not required. Mention the two products of glycolysis. So you have to write, mention the two products of glycolysis: pyruvate and ATP molecules. These are the two products of glycolysis. Then we are having another question. Yeah, very important question. What I'm expecting tomorrow again for the theory part is the reducing sugars and invert sugars. Don't question. Reducing sugar and invert sugar. Asle question you can expect. So reducing sugars are the sugars which contains free aldehydic or ketonic group and reduce failing solution and tolerance reagent. हे answer बरेला तुमका marks meta sure. Okay, next we are having denatured protein. I've already discussed. Next, another question what we can expect is about the enzymes. What are enzymes? So enzymes are biological catalysts which increase the rate of metabolism and they are highly specific in nature. Highly specific मतलब every enzyme is specific to a particular substrate. म्हटल्यार खंयचोय एन्झायम घेतलो जाल्यार रिएक्शन खंयचो जावचो ना. फॉर अ स्पेसिफिक रिएक्शन टू अकर वी हॅव टू यूज अ स्पेसिफिक टायप ऑफ एन्झायम. ओके, आतां जशें आमच्या तोंडान आसा, आमच्या तोंडान कितें एन्झायम आसा, दॅट इज द सलायवरी अमायलेज. नाव दिस पर्टिक्युलर एन्झायम वर्क्स ओनली ऑन कार्बोहायड्रेट्स. Okay, so it will break down that carbo starch to carbohydrate. So it will break down the batat, tanur no, sheet. Okay, so तशी करता. Next we are having the difference between globular and fibrous protein. This also question is very important. You can particularly study this particular question. Next we are having monomers of this particular thing that you can see. Then we are having question, yeah, deficiency of which vitamin causes night blindness? It is vitamin A. Okay, name the base which is found in nucleotide of RNA only. You know, it is uracil. So these are very important, like very simplest, like questions are asked, very simple questions are asked. Deficiency disease due to vitamin B are beriberi, chiliosis, conversions, pernicious, anemia, and deficiency caused by vitamin C, which is a very favorite question of Goa Board, that is scurvy. How is scurvy caused? By which particular vitamin scurvy is caused? Okay. Next. Okay, so then we are having write the name of the two monosaccharide obtained on hydrolysis of lactose sugar. Why vitamin C cannot be stored in our body? This is also very important. But vitamin C related questions are very important. Okay, so that question is why vitamin C cannot be stored in our body. So if you're looking at the question, because vitamin C is the water soluble, it is excreted out of the body. If it is fat soluble, then it is basically kept in our body, it remains in our body. But if it is water soluble, then it will get dissolved in the water and it will be excreted out of your system. Okay, next we are having different types of vitamins, milk, butter, kidneys, and हे ते सगळे किती vitamin दिता आणि हे खाल्ल्यार आमकां बरें आसा. Because vitamin A we get it from milk, butter, kidneys. Kidney आता कोणाचे खातले म्हाका खबर ना. Egg yolk, liver, fish oil, etc. Vitamin D we are getting it from butter, liver, kidneys, again kidneys, egg yolk, fish oil, etc. Now what deficiency it is causing, that is also mentioned in the particular PDF. Okay, so these are the questions what I have mentioned. These are the important questions mentioned in the PDF. The another important question is what are the proteins which are present in keratin. Keratin is what which is present in your hairs, nails. Okay, these are, that is the fibrous proteins. Okay, so moving on to the next PDF, we are moving to which PDF it is. Yeah, DNF block, important Q&A. So DNF block, important Q&A. If you are talking, then okay. Already we have discussed only. Already we have discussed everything. You just need to understand की question कशे येता आणि त्याचे answer आम्ही कशे बरोवप. That is what you need to discuss. We need to discuss about it. So the elements of 3D transition series are given as scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Te question asa. Answer the following questions based on this particular series. This is the 3D series. Okay. Now write the element which shows the maximum number of oxidation states. So among 3D series, असे question येऊ शकता तुमका की which particular element from the 3D series shows the maximum number of oxidation state. So it is chromium. Okay. Can you tell me how many oxidation states chromium shows? आवाज येणार आहे माइक. You cannot hear. Yes, can you hear? All of you can hear? Yes, +2 to +6. +7, it is for manganese. Okay. Yes, yes, very good. Okay. +2 to +6. Okay, that is for this particular thing, chromium. But what is the actual answer that we have done? That is a mistake in this PDF. What is the maximum answer? It is +7, because +7 is exhibited by manganese. So the answer here is not that is, sorry, I took this one. Manganese, it has the maximum unpaired electron, so it is showing the maximum oxidation state, that is +7. That is the maximum oxidation state in the 3D series. Next question: which element has the highest melting point? The highest melting point is exhibited by chromium. Next is, which element shows +3 oxidation state? It is +3 oxidation state is shown by scandium. And the last one: which element is strong oxidizing agent in +3 oxidation state, and why? So manganese Mn3 plus to Mn2 plus results in the stable half filled D5. Now see, very important question which I've seen in many previous year papers. The question is that why basically किती म्हणता manganese is a असे आता हांगासून असे क्वेश्चन आता, why manganese is a strong oxidizing agent. So you can write this particular answer, that manganese +3 to +2 results in a stable half-filled D5 configuration, and that's why it is a very strong oxidizing agent. Okay. So there's a question. Next, why do transition elements show variable oxidation state? That is very also important question to be asked. Then name the element showing maximum oxidation among the first series that we have done. It is the manganese. ते परत असे repeated असा. How would you account for the following? Give reasons. Give reasons आता from D block elements. That is, the transition elements have higher enthalpy of atomization. Because of strong metallic bond, they have stronger interatomic interactions. Now, what is the meaning of higher melting points? Meaning की ते असा की जे ट्रान्झिशन एलिमेंट असता पळय तेका आमी इझिली आमी तेका कितें म्हणटा सेपरेट करू शकना इंटू एटम्स. Why? Because when the transition elements are bonded, no, then they are having very strong metallic bonds, and to break these strong metallic bonds, we require more amount of energy. If more amount of energy is required, then the melting point and boiling point चे temperature असतात ते rise जाता, high जाता. So that is what is about this. Next, the transition metals and their compounds are found to be good catalysts in many processes. Now, why they are good catalysts? They have already sangla, because they are capable of exhibiting variable oxidation state and forming complexes. So they will form a complex, they will act as a catalyst, they will show variable oxidation state, and because they show variable oxidation states, they form many complexes. And if they form many complexes, some complexes acts as a catalyst. Okay. So ते झाले variable oxidation state, same thing asa. Yeah, these types of questions we can expect for transition elements. First question is, chromium +2 is a strong reducing agent. Why it is a strong reducing agent? Because chromium is more stable in +3 oxidation state due to the stable T23 configuration. Next, titanium 3 plus is colored, whereas scandium 3 plus is colorless in aqueous solution. असलो एक variable question येता about copper and zinc. कि copper 2 plus colorless color असा and zinc is colorless. Why it is like that? Same thing, and the same thing will be applied. The answer, because of the completely filled orbital in ground state or in any of its oxidation state. Because हांगा पळय तुमका सांगलेले completely filled orbital असा, that will show no color. आणि empty असा जाल्यार सुद्धा no color, but it is having incompletely filled, then it shows color. So colorless and color. So the most stable common oxidation state of lanthanoid is +3. Out of the following transition element, the maximum oxidation states is shown by which one? That is manganese, we know. मागीर आनी कितें आसा which I can discuss particularly. Yeah, related to chromium also, your questions you can particularly study that is chromium 2 plus is reducing in nature, while the same d orbital configuration, that is d for manganese 3 plus, is oxidizing agent. You have to mention that chromium 2 plus is reducing as its configuration changes from d4 to d3. अशेच बरोवपा जाय हा. हे सगळे तुम्ही अशेच बरोवपा जाय. You cannot write anything else. You have to write this particular thing. रट्टा मार म्हणून सांगिना, but these are the scientific words. So chromium 2 plus is reducing because its configuration changes from D4 to D3, the latter having half filled T2G levels. Whereas manganese, अगर T2G level तुम्हाला खबर असा, it is the lower energy level which becomes more stable. So whereas manganese 3 plus to manganese 2 plus results in half filled orbitals which are for d5. हे तुम्ही नाव बरयले सुद्धा जाता T2G केन्ना केन्ना हे एक्सपेल्ड केल्या सुद्धा जाता, but these things from D2 to D3 and basically it is resulting from the D5 हे तुमका बरोवपाकूच जाय. Okay, this is very important. Next we are having in a transition question किती असा, in a transition series of metals the metal will exhibit the greatest number of oxidation state occur in the middle of the series. कित्याक अशें बी क्वेश्चन येता की मॅक्सिमम नंबर जो एक्झिबिट करता पळय, फॉर एक्झाम्पल आमी थंय पयले सिरीज स्कँडियम टायटेनियम सगळे पयले मदीं मॅग्नीज आसलो आनी तो चड ऑक्सिडेशन स्टेट्स एक्झिबिट करतालो. ते विचारता अशें कित्याक जाता की मदलो जो एलिमेंट असता तोच चड ऑक्सिडेशन स्टेट कित्याक दाखयता. दॅट इज अ व्हेरी गुड क्वेश्चन टू बी आस्क्ड टुमॉरो. So in a transition metal series, the oxidation state first increases and then decreases. At the middle, it is maximum due to the greater number of unpaired electrons in n-1d and ns orbital. हेच अशें काढून तुम्ही पेस्ट करपा जाय. पयली ते increase जाता आणि मागीर ते decrease जाता. It is like donger. कितें? It is donger. स्टार्टिंग सिरीज जाता अशें अशें इन्क्रीज जाता आणि मागीर ते अशें अशें डिक्रीज जावपाक लागता. जो मदीं असता तेजे कडेन मॅक्सिमम नंबर ऑफ n-1 d and ns electrons असता. So maximum number of unpaired. So maximum number of unpaired will result in maximum vacant places and maximum vacant places will give you maximum oxidation state. So this is a very important question to be kept in your mind. Okay. So next we are moving to the another PDF, that is what we are having for a discussion is about coordination compounds. Okay. Coordination compounds जैसा कह गेलो coordination compounds. Okay. Coordination compounds. So if you are moving to coordination compounds of PDF, then we are having, okay, first BBT magir de पहिली isomerism nomenclature. Coordination compounds. Now in this coordination compounds, okay, we don't have to go towards this particular PDF. I will directly go to the nomenclature wala PDF. Okay, just for the idea and the students who can score their marks in the exam just by studying nomenclature. कित्याक 2 मार्क्स तरी मेळटले नॉमेनक्लेचर केले जाल्यार तुम्ही. ओके, लाईक करा मरे. किती रे तुम्ही 133 केला फक्त. लाईक करा आणि चला. लाईक करा आणि चला. राव कोण म्हणता तुमका? रावताल्या राव रे, तस का प्रॉब्लेम ना. Nomenclature of coordination complexes. All of you please pay very good attention. थंय सारखे एक्सप्लेन करून ना कित्याक हे दाखोवपाचे असले म्हाका. मागीर कितें जातलें थंय फक्त एक्सप्लेन केलें हांगा गेलें टाइमपास मरे. ओके. सो मागीर तुमकां क्विज आसा फॉर दिस. यू कॅन जस्ट कॉपी, यू कॅन जस्ट क्लिक अ फोटो बिटो कितें करता जाल्यार तुमी फोटो क्लिक करा, स्क्रीनशॉट क्लिक करता करा, बिकॉज आय एम मूविंग असाइड लायक दिस. ओके. So nomenclature of coordination compounds, we have to know that what is the anion name, we have to know what is the ligand name, we have to know what is the neutral ligand, we have to know what is the ligand name, we have to know which is the metal. So हे सगळे तुमका खबर असपा जाय. Okay. So first thing we are having anion name, we are having bromide, that is Br minus, carbonate CO3 2 minus, chloride Cl minus, cyanide Cn minus, fluoride हे सगळे तुमका खबर असपा जाय. लिगँड चे नाव कितें जातले? These are the ligands what we are expecting आणि हेच ligands तुमका एग्जामीक येतले. हेजे भायरसून खंयचोच लिगँड तुमका येवपा ना. दॅट इज ब्रोमाइड Br मायनस. तो तुमका लिगँड असतलो म्हटल्यार मदीं असता तो कितें म्हणटा कर्व्ड ब्रॅकेटान असता. फ्रॉम दिस ओनली इट विल कम. ओके. हेजे भायरसून लिगँड काय आसचे ना आनी जे हांव एग्जाम्पल दितलो पळय तेच तुमकां नॉमेनक्लेचराक येतले, तेजे भायरसून येवपा ना. ओके. So we have to write bromo, carbonato, chloro, cyano, fluoro, hydroxo, oxalato, then ethylene diamine, tetraaceto. So you can just write EDTA because this is the polydentate. Okay, oxalate is also a polydentate. So next we are having neutral ligand. आता neutral ligand खंयचे असता? अमोनिया neutral ligand. याद दवरा, अमोनिया is a neutral ligand. त्याचा चार्ज काय आसना. We are talking about water, it is a neutral ligand. तेका काय चार्ज आसना. We are talking about carbon monoxide, it is a neutral ligand. तेका काय चार्ज आसना. आम्ही झिरो घेता डायरेक्ट तेका. आणि मागीर इथिलीन डायमाइन EN म्हणून असतले. इथिलीन डायमाइन अशें आसचे ना. EN म्हणून असतले. ENाक बी चार्ज झिरो असता. सो तुमकां ऑक्सिडेशन स्टेट कॅल्क्युलेट करपाक ते खूप बरे आसा. मागीर तेजें नाव कितें? अमाइन. वॉटरचे कितें? अक्वा. कार्बन मोनॉक्साइड कितें? कार्बोनिल. आणि इथिलीन डायमाइन कितें? इथिलीन डायमाइनूच बरयता आमी. नेक्स्ट मेटल आसा. आता मेटल कितें आसा? एल्युमिनियम वी रायट इट एज एल्युमिनेट. क्रोमियम वी रायट इट एज क्रोमेट. Cobalt we write cobaltate, copper we write cuprate, or gold we write orate, iron we write ferrate, manganese we write manganate, nickel we write nickelate, platinum we write platinate, zinc we write zincate. Okay, now this is only applicable when the coordination sphere is having a negative charge. त्यांनाच बरयता. म्हटल्यार एका पॉझिटिव्ह चार्ज असतलो बाबा, elements, the metals will be having a positive oxidation state only, but the total charge of the coordination complex जे usually plus आसपास आहे. जशा पहिली केल्ले पळय आमी, पहिली कितें केल्ले आमी दाखयता आता. पहिली आमी केल्ले पळय, we have written like this, no, we have written like cobalt, then we have written NH3, then we have written 6, and we have written Cl3. Okay, हांगा बरयल्ले एका सेपरेट केल्या उपरांत we have written cobalt, then we have written the amine, and हेका सेपरेट केले म्हटल्यार हांगा हेका सेपरेट केले म्हटल्यार हांगा -3 जाले, आणि हेका हांगासून सेपरेट केले म्हटल्यार हेका टोटल चार्ज कितलो +3. नाउ दिस कोऑर्डिनेशन स्फियर इज हॅविंग अ +3 म्हटल्यार पॉझिटिव्ह चार्ज असा. म्हटल्यार हांगा जे हे कोबाल्ट असा पळय तेका कोबाल्टूच बरयतलो हांव, कोबाल्ट बरयतलो. बट what if the condition reverses and I get like this? Okay, K2 magir cobalt, then I get it as NH3, and I get it as, okay, like this. Okay, NH3 5, and I get it like this. So then आता ह्याचे जे ऑक्सिडेशन स्टेट असतले पळय, this particular oxidation state will be coming in positive only, but ह्याचे नाव जे असतले पळय ते कोबाल्ट बरोवचो ना. आता हांव बरयतलो कोबाल्टेट. ओके, अनमोल टेट. ओके, एंड्रू टेट जाना मरे. सो कोबाल्टेट. ओके, अशें नाव बरयतलो. कित्याक बरयतलो? बिकॉज हे पोटॅशियम जो आसा पळय ते पॉझिटिव्ह. सो पोटॅशियम विल बी हॅव्हिंग हियर +2, मिनिंग हेका काढलो. नाउ दिस टोटल जर हो हेका काढलो जाल्यार हो आपलो पॉझिटिव्ह चार्ज घेऊन वयता. आता हे जे आमचे कोऑर्डिनेशन स्पियर आसा पळय स्क्वेअर ब्रॅकेट, नाउ दिस पर्टिक्युलर स्क्वेअर ब्रॅकेट हे फक्त एक्झाम्पल हा, दिस इज नॉट अ परफेक्ट क्वेश्चन. Okay, this particular thing will be getting a total charge. जर एका +2 असा जाल्यार हांगा -2 असतले. But this is not possible, this is wrong actually. हे wrong दिला, क्वेश्चन wrong दिला. कन्सेप्ट तुम्ही समजा की जेन्ना बी तुमका लेफ्ट साइडीन कोण पोटॅशियम दिसता, सोडियम दिसता, जाल्यार तुमका डायरेक्ट खबर आसपा जाय की कोबाल्ट बरोवचे ना आमी मेटलचे नाव अशें बरयतले. एल्युमिनेट, क्रोमेट, कोबाल्टेट, कुप्रेट, ऑरेट, फेरेट, मॅग्नेट, निकलेट. हे केन्ना? जेन्ना लेफ्ट साइडीन कोणतरी अटॅच असा. ओके, लेफ्ट साइडीन चडशे अटॅच असता तेन्ना हांगा कोण आसना, ह्या साइडीन कोण आसचो ना, बिकॉज दिस इज एक्टिंग एज अ कॅटायन and this coordination sphere is acting as a anion. If coordination sphere is acting as a anion, then the metal has to be named like this. Is this clear? Yes. Now हे तुमका ऑलरेडी सांगला हांवें की if the ligand is having more than one ligand, then 2 आसा जाल्यार डाय बरयता, 3 आसा जाल्यार ट्राय बरयता, 4 आसा जाल्यार टेट्रा बरयता, 5 आसा जाल्यार पेंटा बरयता, आणि 6 आसा जाल्यार हेक्सा बरयता. चडशे 6 मेरेनूच आमकां क्वेश्चन्स येता till 6. Okay, so ammonia asa, ammonia is having ammonia, if it is having ammonia अशें आसा NH3 आणि 5 आसा, then you write it as पेंटाअमाइन अशें बरयता, पेंटाअमाइन अशें बरयता. 4 आसा जाल्यार टेट्राअमाइन, 3 आसा जाल्यार ट्रायअमाइन. नाउ दिस इज ओनली फॉर द कितें म्हणटा आमचे मोनोडेंटेड, डायडेंटेड, एम्बिडेंटेड. बट इफ यू आर गोइंग फॉर द बिगर dented ligands, denticity. Okay, that is also a very good question. Okay, what is denticity? Dentist know what is denticity. So if they are moving for the next one, then if the ligand has di, tri, tetra, its name is dented molecule you want to indicate. But if you want to indicate you have more than one of them, meaning हांगा आमचेकडे एक कॉम्प्लेक्स मॉलिक्यूल आसा आणि तेका आमकां नाव दिवपा जाय which is not just like simple ligand, then we give it as 2, we write it as bis. This applies only for polydentate ligands. पॉलिडेंटेड व्हडले लिगंड जे आसा पळय आमचे ऑक्झॅलेटो आसा, मागीर आमचे ते EDTA आसा. सो वी डोंट रायट इट एज डाय EDTA or डाय ऑक्झॅलेटो, वी रायट इट एज बिस, ट्रिस एंड टेट्राकिस. ओके, टेट्राकिस, 4 किस ना रे, 4 किस न्हू बाबा, फगाणा करता. बिस म्हटल्यार 2, ट्रिस म्हटल्यार 3 आणि 4 मिनिंग टेट्राकिस. ओके, so तशेंच आता तुम्ही हांगा पळयात द डेंटेट्स what you are talking about, biodentate 2 bites, oxalate, ethylene diamine and malate. So tridentate 3 digits we are getting for citrate, hexadentate we are getting it for EDTA. Okay, now these are the bigger compounds. जेन्ना तुमका oxalate दिसता आणि 240 असा, then you write bis oxalato. Oh, Okay, so like that we have to write. So now how to name complex ions that are positively charged. So तुमका already सांगला आहे positively charged असता तेंका आम्ही cobalt बरयता, iron बरयता. You can write ferrous also, no problem. You can write nickel, you can write copper. So हांगा आम्ही cobaltate बी तशे कायच आम्ही करिना. Now, every compound has a both positive charge part and a negative charge part, like the NaCl is really NaCl. The same is true. Raw material. Okay. Example: if we are talking about in the above example, give several positive name and the also negative part goes with the consider the following. So we are having positive and we are having negative. आता हांगा मेरेन आम्ही coordination pair करता. Here it is not mentioned actually, so I will just mention it over here. You can just see that it is like this. Okay. It is like this. So a biton asa or bayar asa. A biton asa and this is outside. A biton asa and this is outside. A biton asa and this is outside. Like this. Because Goa Board is asking like these questions. So you have to write hexamine, cobalt 3, chloride. आता cobalt 3 कशे आयले तुमका सांगला. You have to solve it like this. X plus then ammonia also घेतलो 0. Then we are having total म्हटलं minus 3. No, so it is going out. So equals minus 3. So it is like X is equal to plus 3. So like this you have to calculate. That's why we are getting the plus 3 chloride state. Now if you're talking about EN, हे तुमका दाखवपाच असलो. EN असा, आता हांगा पळय वॉटर असा, NH3 असा आणि कार्बन मोनॉक्साइड असा. These are all like a single, no, okay, like monodentate or didentate. But if you're talking about this particular thing, that is the polydentate ligand, that is the ethylene diamine. Ethylene diamine जेन्ना येता पळय तेन्ना आम्ही कशे बरयता कितले फावटी असा ethylene diamine 2 फावटी असा. So we don't write it as diethylene. This is the ligand. Ethylene diamine is a ligand. So we don't write it as diethylene diamine. We write it as bis because it is a polydentate ligand. So bis असे करता आणि मागीर ब्रॅकेटान लायला डॅश घालू शकता तुम्ही. इथिलीन डायमाइन मागीर निकल घालता मेटल एंड निकलचे ऑक्सिडेशन स्टेट कितें 2 आसा एंड वी राइट इट सल्फेट. आता इथिलीन डायमाइन which is having basically I told you already, I have shown you that it is having the oxidation state 0 असता. सल्फेट as oxidation state कितलो असता, it is 2 minus. So सल्फेट भायर आसा असो, सल्फेट असो 2 minus आसा आणि हेजो 0 आसा जाल्यार this 2 minus the opposite किती आसा, it is plus 2. So plus 2 हांगा आसा for this and this is directly applicable to the nickel. So त्याच्या खातीर nickel oxidation state plus 2 आसा आणि as we are having ions on the right side जेन्ना आमच्याकडे ion असता we write the name directly like iron, cobalt, nickel तशे. But left side in जर किती आसा then we write the metal name as cobaltate, ferrate, nickelate and cuprate. I hope this is clear about this particular thing. Rest चढ कितें हितून करपाची गरज ना. नेगेटिव्हली चार्ज हे सगळं तुमकां सांगलें हांवें की लेफ्ट सायडीन जर कितें आसा जाल्यार ते करपाचे, रायट सायडीन आसा जाल्यार ते करपाचे. आतां तुमकां एग्जांपल दिता एक रायट सायड हो पळय आमचो भाऊ. हेजें नांव म्हाका तुमी सांगतले आतां बेगीन. यू वील प्रॅक्टीस इट एंड वी वील प्रॅक्टीस इट रायट नाव. टेल मी द नेम ऑफ दिस वन. कम ऑन बेगीन. नाव सांगा. लेट अस प्रॅक्टीस नो. प्रॅक्टीस जावपा जाय गायस. प्रॅक्टीस जावपा जाय टाक करून. बेगीन. आय नो दॅट यू आर सिटिंग विथ अ बुक एंड पेन. So just write it and तेजें नाव सांगा म्हाका. बेगीन. Come on guys. बेगीन नाव सांगा म्हाका. फाल्यां पेपर आसा, फकाणां नाका. Let us get through this together. Okay. कितें नाव आसा? K4FeCN6. Come on, fast. Okay. Then hexacyanoferrate potassium. लेफ्ट सायडीन जे नाव असता पळय ताजे नाव आमी पयलीं बरयता. जो कोण लेफ्ट सायडीन आसा पळय तो बाबू K4 तेजे नाव पयलीं येतलें. Okay, Thunder Gaming has mentioned potassium cyanoferrate. Okay, but still it is not complete. Logical has written potassium hexacyanidoferrate 2. Okay, potassium hexacyanoferrate 2. Okay, cyanidoferrate and cyanoferrate both are absolutely correct answers. Okay, cyanido बरयला जाता तुम्ही, but usually I will prefer you go with cyano. बट थोडे स्कुलान हांगा एक स्कूल आसा थंय बी स्कुलान तांकां सायनिडो बरें म्हूण सांगला. बट आय प्रिफर टू रायट सायनो बिकॉज म्हाका तशें शिकयल्लें इन माय ग्रॅज्युएशन, नॉट इन 11th-12th. 11 12 शिकवंक ना 11 12 म्हाका खबरूच ना कोऑर्डिनेशन कंपाउंड चॅप्टर आहा म्हणून. Okay, hexacyanidoferrate. Okay, hexacyanidoferrate, potassium hexacyanoferrate. Yes, absolutely correct. It is potassium hexacyanoferrate. Now, the potassium point, this particular K4, no, it is on the left side. So, त्याच्या नाव पहिली येता. So, we write it as potassium. Then we write it as hexacyanoferrate. पय फेरस बरोवंक ना आयन बरोवंक ना फेरेट कित्याक बरयला बिकॉज लेफ्ट सायडीन हो आसा दॅट्स वाय वी रायट द नेम डायरेक्टली आमकां खबर आसा हो गेलो न्ही हो भायर सरलो की हेजेर फूल चार्ज कितलो येता नेगेटीव चार्ज इफ दिस इज बिकम बिहेविंग एज एन आयन एनायन मीन्स नेगेटीव चार्ज देन हेजें नाव अशें येता आतां ऑक्सिडेशन स्टेट कितलो आसा इट इज 2 ओके very good very good guys very good everybody very good you have done well potassium hexacyanoferrate 2 and you have to write in a together potassium ashya line and take on borop space ghal naka okay very good so this is the practice sheet what you can practice same thing goes with this one name this one fatafat easy asa yes amke easy asa yes kachro mare हे कायत न्हू अशें आसा ते okay it is basically coming like this सांगा म्हाका नाव सांगा तेजे बेगीन कम ऑन गाइस बेगीन सांगा आणि व्हिडिओ लाईक करा मरे किती रे लस करता मरे तुम्ही 158 200 सांगला तुमका 200 जावपा जाय लाईक करा व्हिडिओ येता तुम्ही विचारता गर्लफ्रेंडाचे थोटान रावता मागीर तुम्ही असे ते किती शिकता आसतले म्हणून ओके राईट व्हॉट इज दिस वन ओके समरस गिवन लॉजिकल देन FM2P कितें नाव बरयता बाबा तुम्ही ओके प्लॅटिनेट डाय नाही बाबा तसे कसे बरयता तू हाव यू आर रायटिंग लायक दॅट प्लॅटिनेट ओके तो लेफ्ट सायडीन आसा तेजें नाव डायरेक्ट आमी अशेंच बरयतले नॉर्मल इट इज प्लॅटिनम ओके तनिष्का मांजरेकर just check your spelling please you've written okay but you have to write the spelling okay platinum spelling diamine platinum ना रे बाबा पहिली पो platinum भायर आसा मरे तेजे नाव पहिली बरोवप you have to write the name of the platinum first बेगीन सांगा Sia is mentioned platinum tetraamine chlorido 4 okay wait no. I gave you the question wrong. Sorry. अगं ते अशी चूक झाली. Sorry It is not like this. It is like this. आता सांगा. Sorry. Really sorry. I misjudged. असे या. Hello. Sorry. चूक झाली Really sorry. Okay, sorry guys, I put the coordination pair wrong. Okay, माझी चूक. So तुम्ही आता म्हाका सांगा हेजें नाव. Now you can name it properly. Sorry, really sorry. माफ करा. हात सोडटा. Sorry. आज 161 बेगीन झाले. म्हाका 200 जाय like. Okay, right. What is the name of this one? Now you can write it. It is diamine platinum 4 chloride. Okay, diamine platinum 4 chloride because it is very obvious. Amine असा म्हटल्यार 0 असा आणि chlorine चा असा म्हटल्यार -4. So this is +4 and this +4 is directly for platinum. So you can write it as diamine platinum बरयता platinate बरयना because it is not behaving because it is having a positive charge. Platinum 4 chloride. Okay, this is the name you have to write. Okay, yeah. So we will not waste much of our time in this particular thing. Nomenclature खूप जाणां घेता आसतले कोणाक येना ते प्रॅक्टिस करा सारखे प्लीज हांगा मागीर दिलेले आसा ते सगळे प्रॅक्टिस करपाक आनी आसा and answer की बी दिलेली आसा with the names everything it is given हे प्रॅक्टीस करपाचे एकदा प्रॅक्टीस करपाक कळ्ळें की जालें पावले तुमी ओके सगळे आसा आनी हांगा ते हे दिला this is for the VBT sort of like yeah but these questions are usually not asked but you can just identify D8 electron D5 so this thing is you can skip this one yeah okay so moving towards the next PDF what we are having it is next PDF coordination okay nomenclature 2 म्हणून असा PDF nomenclature 2 again it is just practice sort of so we can do that practice because थोडी भुरग्यांक ते तरी marks मेळोनी yes so if you're looking at this particular thing worksheet nomenclature then name the following compounds it is already given how it is given पळय हांगा K3 भायर आसा सो पयली तेजे नाव आसा पोटॅशियम then कितले फावटी फ्लोरीन आसा 6 फावटी so hexa fluoro आणि now if we are having on the left side this is behaving as a negative charge if this is behaving as a negative charge then we write it as ferrate आणि कितले फावटी ferrate it is 3 times okay so हे आता कशे येले 3 कशे येले हांगा 6 आसा that you have to do with the help of that formula okay formula it's a step so you have to write it like this potassium आमका खबर आसा potassium is giving us +3 okay so +3 तो भायर गेलो so हेजेकडे उरले टोटल चार्ज कितले उरले हांगा Fe F6 and this is having -3 now if it is having -3 that means fluorine is giving -1 so fluorine कितले फावटी आसा 6 फावटी आसा so fluorine is having actually -6 so आमका हे खबर ना ion चे so we take ion as x and we put plus into -6 घालता equals to -3 so x is equal to -3 आणि हे 6 हांगा धाडटा +6 so it comes to +3 that's why we got for this we got +3 okay like this तुम्ही सॉल्व करपाचे जाल्यार मागीर परत तुम्ही व्हिडिओ रिवाइंड करून पळयात I am moving forward with this one I just wanted to show you this again write the formula for each of the following complex so तुमका नाव दितले आणि फॉर्म्युला बरे म्हणून सांगतले आणि जे हांगा दिला पळय in this हांगा 8 आसा मागीर हांगा परत 7 आसा from this the question to come the probability is very high okay for the nomenclature sort of and also for VBT also so we can VBT भी तुम्ही करू शकता हांगा VBT चे भी क्वेश्चन तुमका दिता हांव ऑलरेडी so ते तुम्ही करपा शकता next we are moving to the other PDF which is the PDF next one you have to go that is ते झाले nomenclature झाले okay coordination isomerism just पळयात तुम्ही isomerism चे क्वेश्चन येतात 2 मार्क्सा खातीर शुअर क्वेश्चन येता okay yes smart VBT also I'll be showing you after this we'll be going for VBT only ओके लाईक करा रे तुम्ही येता वयता टाइमपास करता लाईक करा व्हिडिओ आयझोमेरिझम इन कोऑर्डिनेशन कंपाउंड तुम्ही म्हणटले कितें सर बीग मागता म्हण लायका खातीर बेश्टे रे टाइमपास करता लाईक करा मरे तुम्ही okay the coordination compound which have the same molecular formula but are different but have the ligands attached to the central metal atom in a different ways म्हटलं ऍक्च्युअली पोवंक गेल्यार न्ही the coordination compound will be having the actual like same formula हो सुद्धा आणि दुसरो सुद्धा but पोवपाक गेल्यार it is like if you're looking at the structure how it is structured खंय आयन आसा खंय एनायन आसा खंय सेंट्रल मेटल लिगंड आसा सेंट्रल मेटल लिगंड सेपरेट जाल्लो आसा मागीर एनायन सेपरेट जाल्लो आसा बट इफ यू आर लुकिंग एट द टोटल नंबर ऑफ क्लोरीन कितले आसा टोटल नंबर ऑफ अमोनिया कितले आसा टोटल नंबर ऑफ आयन कितले आसा इट इज सेम इन बोथ द कंपाउंड्स जस्ट structurally it is different that's why we are having the structural isomers and structural isomerism what we are having there are 4 types and that you will be looking over here सो डायरेक्टली तुमकां दाखयता हांगा कितले आसा हे तुम्ही पळयात आणि सारखे रिवाइज करा इट इज व्हेरी इम्पॉर्टंट ओके 2 or more molecules you identify ते सोडा हांगा आर bonds between the same atom no so we are having the structural constitutional isomers ionization isomer linkage isomer coordination isomer and hydrate isomer 4 important asa and from this we are getting 2 types that is basically we are getting the geometrical isomers and we are getting the optical isomers now in these geometrical isomers we are not getting any chiral carbon hanga chiral carbon asta non superimposable asta so we are calling this particular type of optical isomers as enantiomers very important question what are enantiomers okay so any geometrical isomers are not enantiomers because they form the superimposable mirror images zata but actually it is superimposable so we are not getting it but you don't consider that particular topic over here you just consider over here enantiomers okay so isomerism structural isomerism first one is ionization isomerism just tumka example explain karta then you will understand ki jar ashe question ele jale ami kashe borow shakta okay so if we are doing here then compounds with the same formula but which give the different ions in solution exhibit ionization isomerism. म्हटल्यार कितें आसा, कंपाउंडाक सेम फॉर्म्युला आसा पूण तो आयन्स आसा पळय ते आयन्स सेपरेटेड आसा. फॉर एक्झाम्पल इफ यू लुक ॲट दिस पर्टिक्युलर एक्झाम्पल, सारकें पळय एकदां पयलें कळटलें. प्लॅटिनम अमोनिया आसा, क्लोरीन आसा आनी ब्रोमीन आसा. हांगा बी प्लॅटिनम अमोनिया ब्रोमीन आनी क्लोरीन आसा. कितले प्लॅटिनम? हांगा एक प्लॅटिनम, हांगा एक प्लॅटिनम. कितले अमोनिया? हांगा 4 अमोनिया, हांगा 4 अमोनिया. कितले ब्रोमीन? हांगा 4 ब्रोमीन, हांगा 4 ब्रोमीन. कितले क्लोरीन? हांगा 4 हांगा 2 क्लोरीन आनी हांगा 2 क्लोरीन. But totally if you look that this is having actually the same formula, but the only point different is that हांगा ब्रोमीन आसा तो anion behave करता आनी हांगा क्लोरीन आसा तो anion behave करता. So when it is dissolved in a solution, हे separate जातले as a positive and हे separate as a positive, but in one solution I will get bromine as ion and I will get chlorine as ion in the another solution. So this is called as ionization isomerism, wherein different types of ions are seen of the same type of compound but different. So it is like ionization isomerism. Second question तुम्ही पोहू शकता. Next question आणि एक असा, that is here. So cobalt NH3 Br sulfate and cobalt NH3 sulfate. हेच दोन एक्झाम्पल बी येऊ शकता एक्झामिक तुमचे. Okay, so this is showing a violet color in the solution, this is showing the red color in the solution. Why? Both are same only, but it is showing different colors. Why it is showing different colors? Because this is giving sulfate and this is giving bromine. Again, next one we are having cobalt NH3 NO2 Cl and Cl, and here we are having cobalt NH3 Cl2 and NO2. ना आता तुम्ही सांगतले म्हाका क्लोरीन भितर आसा, हांगा नायट्रेट भितर आसा पण क्लोरीन भायर आसा. बट इफ यू लुक एट द टोटल नंबर, देन कोबाल्ट एक आसा, अमोनिया आमचेकडे 4 आसा, नायट्रेट आमचेकडे 1 आसा, क्लोरीन आमचेकडे 2 आसा, पण एक भायर गेला दॅट विल बिकम इनटू आयन आणि एक भितर उरला. बट टोटल इट इज सेम. हांगा 2 क्लोरीन आसा, 1 नायट्रेट आसा, तो भायर आसा. सो आता कितें जातले, जेन्ना डिसॉल्व करतले, दिस पर्टिक्युलर विल डिस्पोज द क्लोरीन and this particular will dispose the nitrate. But totally if you look at the formula, then both are having the same molecular formula, just it is showing a type of isomerism which forms different types of ions when dissolved in a solution. That is called as ionization isomerism. I hope this is clear. Next one, we are moving to linkage isomerism. I will have to go in some time to break my fast, so I will come in 10-15 minutes. Not 10-15 minutes. रोकडा येता 2 मिनिटांनी. Okay, so if you're looking for this particular thing, the linkage, that is the ambidentate linkage happens with the ambidentate coordination compound. Ambidentate म्हटल्यार हो आसा. Okay, हो आसा आमीर. Okay, आमिराक कोण हांगासून ओडटा आणि आमिराक कोण हांगासून ओडटा. आमीर is okay with both the hands because आमीर is having 2 hands. हांगाच्यान कोण म्हाका ओडू शकता, हांगाच्यान कोण म्हाका ओडू शकता. पूण हांगा जर आमिराकडे हातूच ना जाल्यार आमिराक फक्त लेफ्ट हँडान ओडचे पडटले. खावपाचे बी लेफ्ट आणि धुवपाचे बी लेफ्ट. ओके, बिकॉज नात न्ही. हांगाच्यान कशें ओडटलो, जागोच ना, हेच ना मरे, सिस्टमूच ना कितें. सो दिस इज कॉल्ड एज मोनोडेंटेड. मोनोडेंटेड म्हळ्यार एकूच जाग्यार अटॅचमेंट. कसो तुवें म्हाका आपय, हा असो 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 एकच सायडीन. बट एम्बिडेंटेड काम, अशें अटॅच, अशें अटॅच. ओके, so that is how we talk about. And this ambidentate ligands which are present in a coordination compound, they show what type of isomerism? They show linkage isomerism. Okay, Krish sir 25 marks चे शुअर शॉट तेच सांगता सारखे लक्ष देऊन मन लावून सामके शिक. Okay, okay, some ligands can bond to the metal, ते सगळं तुमका सांगले आता. Now what are the examples and what you can get in the isomerism? You can get this particular thing, MSCN. So we are having the metal attached to the SCN. SCN is the thiocyanate isomer. SCN असता आणि NCS असता. One time it is getting attached with the metal with sulfur, and one time it is getting attached with the metal with the nitrogen. So हांगाच्यान बी attachment असा पळय, SCN परते कर मरे, just inverted. SCN becomes NCS and NCS becomes SCN. So हांगाच्यान बी हात असा तेका ओडपाक, हांगाच्यान बी हात असा तेका ओडपाक. So that is called as the ambidentate ligand, and ambidentate ligand shows the linkage isomerism. Link खंयच्यान जाला? Link is happening with right hand or left hand, but link is happening. Both are ready to form the link. Just the thing is, it is having different positioning. So you can just look over here and how it is happening. Same thing we येऊ शकता examining issue ना. So cobalt, ammonia, ONO asa आणि Cl2 asa, ONO. So basically NO2 nitrate can be also written as ONO. It can form the bond with nitrogen and it can form the bond with oxygen also. So that's why it is called as the ambidentate ligand and it is forming like this. See, AONO, this is called as O isomer and this is called as the N isomer. Okay, so while writing the name also you have to mention that which particular isomerism you are mentioning, O isomer or N isomer. Second is for the NCN thiocyanide, manganese, cobalt, N च्या वांगडा link झाला आणि हे same thing असा but it is just linked with the sulfur. So that is called as linkage isomerism. Link जाता ते different असता but compound is same. Next, having coordination isomerism. In coordination isomerism, what is actually happening? The हांगा तुम्ही पाहू शकता की हे जे माझ्याकडे दोन असा पळय. Here I am having different sort of coordination based on म्हाका कशें जाय तशें हांवें केला, but totally if you are looking, it is the only the same. Now, if you are looking here, cobalt NH3 6 and chromium Cr2, this is oxalate, it is having 3. Here, if you are looking, then we are having the chromium with the ammonia, but here the cobalt is with oxalate. फक्त हे interchange जाता. Okay, they can ask you what is the meaning of coordination isomerism and write one example. You can write this particular example. फक्त किती जाता central metal atom change जाता for the both. So हांगा जे पहिली अमोनिया कोबाल्ट आशिल्लो तो आता अमोनिया क्रोमियम असा. हांगा जे पहिली क्रोमियम हे असले ते आता change झाले. So this is this place. Okay, very easy, you can write it. Next one is hydrate isomerism. What is the meaning of hydrate isomerism? This type of isomerism is similar to hydrate म्हटल्या कितें कितले उदक molecules तेका attach असा भितन भायर. Okay, now if you're looking at the particular question, then if you look here, then okay, the standard example of is this one, chromium Cl3 6 H2O, which can have the three distinctly is dollar a time. What is the time? Time just I will explain this and go. Okay. Then okay, what is actually happening that we are having chromium Cl 3.6 H2O. So water molecules लागला which have three distinctly different crystalline compounds. So याचे आता तीन compounds जाऊ शकता in the crystalline state which will have different types of water arrangement, water molecule arrangement. But same thing, no, it is finally the same thing. So if you look here, we are getting this particular one isomer, chromium H2O 6 Cl3, एक isomer showing which color, violet color. Okay, next chromium Cl H2O 5 Cl point H2O, पण हांगा पण कितले आसा स मॉलिक्यूल, हांगा कितले आसा वॉटरचे मॉलिक्यूल 5 + 1, so it is same. क्लोरीन हांगा 3 आसा, हांगा 1 आणि हांगा 2, it is same, but it is showing which isomerism, water, that's why it is called as hydrate or it is called as solvate isomerism. Okay, solvate म्हटल्या उदका खातीर उलयता आमी. It is showing blue green color. Another असा आमच्याकडे युनिक एक्झाम्पल that is chromium Cl2 H2O 4 असा आणि क्लोरीन आणि 2 H2O बाहेर असा. So 4 + 2 वॉटर मॉलिक्यूल एकच कंपाऊंड आसा बट 2 वॉटर मॉलिक्यूल बाहेर असा. So it is actually having 6 वॉटर मॉलिक्यूल. क्लोरीन 2 हांगा भितर असा, 1 बाहेर असा. हांगा 2 बाहेर असले, 1 भितर आशिल्लो. But total if you are counting, we are having 3 chlorines, we are having 1 chromium, we are having 6 water molecules. This is showing dark green color. So this is called as solvate isomerism. Okay, fine. So till here we have done. I will just go for just give me a break of 10 minutes. Okay, I will come in 10 minutes because I have to go to washroom ata naga. Washroom waita. Okay, just I will go in 10 minutes. I don't have anything to it. I have only got the dates. Date म्हटल्या खजूर. Okay, खजूर लाया है. डेट बोलतो समजी की अंदर कोण बटी आहे बोलगो. डेट बी नाही. त्यात खजूर हाडला, तो खातलो, उदक पितलो, मातशें बसता, थाळो मातसो हे जावनी, and then I will again start and we will finish very early now. Now it is almost over. The VBT ulla, then yeah, done. Okay? Yes. नाका किदे खाऊ नका स्मार्ट भूक लागला मला. I am fasting. I have to break my fast. Nonsense. Okay, let us start again. Begin start करूया. Begin सोपा या वचन बिर्याणी खाता. Chill. अरे किती चालला रे तुमचे नाका रे. पर्सनल पर्सनल नावा घेऊ नका चॅटान. ओके ओके. लेट अस स्टार्ट नाव. खंय गेली रे सगळी जाण. वेट करूया 2 मिनटां येतली दिसता. 2 मिनटां वेट करूया. जाता जाता जॉईन जाता. ए तुम्ही लाईक कितले रे 184 का तुमका 200 सांगलेले मरे 200 करा म्हणून. हा लस करता म्हणजे लस करता 200 करा मरे. ओके सो टिल हियर तुमकां कळ्ळें आसतलें की हाव डिफरंट टायप्स ऑफ स्ट्रक्चरल आयझोमेरिझम्स आसा. स्ट्रक्चरल आयझोमेरिझम 4 तरेचे आसा जे हांवें तुमकां आत्तां शिकयले आनी फ्रॉम दॅट we are definitely expecting one question for 1 or 2 marks. Okay, 2 क्वेश्चन आले जाल्यार 2 मार्क्स, 1 क्वेश्चन आल्यार 1 मार्क. एक नॉमेनक्लेचर, एक आयझोमेरिझम. ओके आणि आयडेंटिफाय करपाक आणि जर ते एक्झाम्पल बरोवपाक सांगता की स्टेट व्हॉट इज लिंकेज आयझोमेरिझम विथ एन एक्झाम्पल देन इट इज बेसिकली कमिंग फॉर 2 मार्क्स. सो ते तुम्ही सारखे करपाचे. ओके या. पॉलिमरायझेशन ते सोडून घाला. पोझिशन बिजिशन दिया नाका आमकां. दॅट इज एडिशनल. That is for the JEE and NEET type of questions. Geometrical isomerism. Okay, geometrical isomerism. This is important because you're having this thing. Geometrical isomerism म्हटलं की now we are not just talking about the structure. We are talking about how the positioning of ions or how the positioning of the different elements are there in a coordination compound. So आमच्याकडे आता जर जॉमेट्रिकल आयझोमेरिझम असा देन वी आर हॅव्हिंग द सेम लिगँड सगळे सेम असता बट द थिंग इज द पोझिशनिंग चेंज जाता. म्हटल्यार पयली कोण वयर अटॅचमेंट असता तेजी आता अटॅचमेंट सकयल असतली, कोणाची ऑपोजिट अटॅचमेंट असता, कोणाची वांगडात अटॅचमेंट असता. सो वी हॅव्हिंग द सीस ट्रान्स बी तुम्ही ऐकले असतले सीस आयझोमर्स ट्रान्स आयझोमर्स. ओके सो नाउ लेट अस लुक एट द फर्स्ट जॉमेट्रिकल आयझोमर्स. Now in this geometrical isomerism this is coming this is coming under stereoisomerism, geometrical isomerism and optical isomerism. Stereoisomerism is the bigger concept like structural isomerism and 4 असा तसेच स्टिरिओ आयझोमेरिझम असा. स्टिरिओ आयझोमेरिझमान आमच्याकडे 2 असता, geometrical isomerism and optical isomerism. Let us see that. So geometrical isomerism आमका different तरेचे structures geometries मेळटा. Different geometries for the same particular compound. That compound can show different types of geometries. Now geometry तुम्ही ऐकले असतले we are having square planar, we are having trigonal, we are having trigonal bipyramidal, we are having tetrahedral, we are having octahedral. एका म्हणता geometry. Okay, so that will be saying. Now if you're looking at in detail the geometrical isomerism, first one in square planar complexes. A square planar complex having similar ligands at adjacent position 90 degree apart is called as a cis isomer, while a square planar complex having two similar ligands at opposite positions 180 degree apart is called as trans isomer. Why I'm explaining this? Because the question can come, no? Explain what do you mean by cis and trans isomers, giving one example for 2 marks. So that can also be expected. सो आता तुम्ही हांगा पळयात तुमकां हे येता सिंपल वर्ड्स. ओके सीस म्हटल्यार कितें ते वांगडाच असता फक्त 90 डिग्री सेपरेट असता लायक दिस 90 डिग्री सेपरेट असता. सो इट इज एडजस्टंट. एडजस्टंट म्हणल्यार तेकोन सायडीकूच आसा तेका म्हणटा सीस आयझोमर. दिस इज अ स्क्वेअर प्लेनार. स्क्वेअर प्लेनार. सो स्क्वेअर प्लेनार ज्योमेट्री आमकां मेळटा हांगा. एंड इन दिस वी आर हॅव्हिंग द अटॅचमेंट ऑफ द लिगँड्स विच आर हॅव्हिंग एट द सेम पोझिशन्स. अशे सेम आसा ते सायडीकूच आसा. हांगा जर पळयता आमी इट इज 180 डिग्री अपार्ट. So it is like हांगाच्यान अशे full round मारल्यार protractor घेऊन then you are getting 180 degree. This is called as trans isomer. Okay, चड हांव काय उलयना हेजे बद्दल. This is the important. You can get it for drawing the structure also. Next we are having the geometrical isomerism in 6 coordinated complexes, that is the octahedral complex. Now if you are getting in the octahedral complex then this is the particular compound. We are getting CONH3 4Cl2 plus and CONH3 4NO2 2. Okay, now in this we are getting the cis isomer and here we are getting the trans isomer. आता आम्ही पोवंक गेल्यार we are basically, if you look at this particular thing, it is having a square. Draw करता. It is having a square. This is a central metal atom. It is attached over here. It is a square. Okay, a square असा 4 आणि 5 आणि 6. So it is basically showing like this. Okay, octahedral geometry. अशे एक डायमंड कशें समजून घ्या तुम्ही, अशें वयर आसा अशें, मागीर ते अशें हे आसता आनी अशें हे आसता. So it is like having this particular geometry, octahedral, and this particular octahedral geometry आमी हांगा पळयता, then it is having two particular isomers for this particular compound. That is, we are getting a cis isomer wherein you can see the positionings are 90 degrees only. Here you can see the 90-degree positioning, and if you are looking at the trans isomer, it is the 180 degree. Okay, 180 degree. हांगा फक्त 90 degree asa. So this is the same compound what we can expect in your exam. Okay. Next, we are having the Ma3B3 type of complexes may have isomeric. So हांगा कितें आसता, हांगा आसता आमचेकडे कितें म्हणटा तेका, facial type of isomerism what we are getting, and FAC तेका म्हणटा आणि तेका मर म्हणटा. Okay, meridian and facial असता. So facial and meridian, which is very rare we are getting. So but still, facial and meridional we are getting. Facial isomers have three identical ligands on one triangular face. Meridian isomers have three identical ligands in a plane bisecting the molecule. So if you look at this particular thing, facial and meridional, then you can see that we are having, firstly, in this particular compound, cobalt asa, ammonia, 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 and it is having all these three, which is not bisecting, but it is together. But if you are seeing over here, then this particular isomers asa, it is bisecting this plane. So that is called as meridional. Okay, facial and meridional. So this particular I'm not actually expecting, but if they ask, then they will give you this particular isomer and they will tell you to draw this particular structures. Now, next, what is important that we have to study is the optical isomerism. Okay, Vijay Kumar Mishra, don't spam. Bahar martlo. Vijay Kumar Mishra, please don't spam. बोलो क्या डाउट है, बोलो. विजय कुमार मिश्रा, बकवास मत करो प्लीज, स्पैम मत करो. Assertion in respective order, half lives are always come only when amount at any time of t of reactor are their stoichiometric ratio. Half life of reaction depend on initial. बाबा ते already ते lives झाले आता. Okay, I cannot basically talk about this because we are having the concept different. If you have any problem, you can just WhatsApp me. I'll put my WhatsApp number. WhatsApp कर मका क्वेश्चन 8788192982. ओके, प्लीज WhatsApp करो. अभी ये हमको टाइम नहीं है ये करने के लिए. हमारा बच्चा है बच्चा का एग्जाम हमारा आता. तो we cannot talk about this thing. We are talking about just the important stuff what we are having. Optical isomerism. Now, what is actually optical isomerism? When the solution of certain complex compound are placed in a path of plane polarized light. So, in optical isomerism, the compound is basically rotating the plane, or like when the polarized light is kept on it, and it is rotating the plane of light into certain direction. एक कंपाउंड असा त्याच्या वयर आम्ही जर पोलरायझ लाईट घालता जाल्यार तो कंपाउंड खंयच्या डायरेक्शन मूव जाता. इट इज मुव्हिंग इदर द राईट पोझिशन और इट इज मुव्हिंग इन द लेफ्ट पोझिशन. बेस्ड ऑन दॅट द रोटेशन ऑफ द प्लेन, जसं प्लेन रोटेट जाता पळय, राईट सायडीन रोटेट जालो की मागीर तो तेका आमी डेक्स्ट्रो रोटेटरी, लेफ्ट सायड जालो की लेवर रोटेटरी, तेका म्हणटा आमी ऑप्टिकल आयझोमेरिझम. सो वी आर हॅव्हिंग डी फॉर्म एंड एल फॉर्म. ओके, so if you can see here on which the rotates the plane polarized towards the right in clockwise direction. So that's right boropna. It can be also mentioned as clockwise direction. So it can be written as dextro-rotatory or D form, or D form is also represented by plus sign. Okay, on which rotates the plane polarized light on the left side anti-clockwise direction rotates jata जाल्यार आमी तेका lever rotatory म्हणटा, L form म्हणटा. It is represented by putting the minus sign. ते तुमकां identify करपा जाय because they might ask you what are the two different types of optical isomerism observed in coordination compounds. The two types of optical isomerisms are dextrorotatory and levorotatory. Dextrorotatory म्हाका explain करपा सांगतले तुमकां ती what is dextrorotatory, or differentiate between dextrorotatory and levorotatory optical isomerism. So you have to explain it, how it is plus, why it is clockwise direction, anti-clockwise direction. Okay. Isomer which is capable of rotating plane is called as the optically okay, optically inactive chair question चढ येना, but what question comes is optically active chair येता. What do you mean by optically active compound, or what do you mean by optically active molecule? So if you know optically active म्हटल्यार it is basically capable of rotating the plane polarized light. It is called optical. Such isomers are called as that is called as it is not superimposable. If it is not superimposable, then these are called as enantiomers. Cone optically active. Okay. If we are talking about the other thing which is not optically active, then these isomers which are not capable of rotating the plane polarized light, it is called as optically inactive. Such isomers are called as mesoracemic, or basically the racemic mixture में question आता. What is a racemic mixture? हो question भी हमें expect करू शकता in your exam. Okay. मागीर आमच्याकडे हांगा आसा ऑप्टिकली एक्टिव. यू कॅन सी हियर, देन यू कॅन सी द राईट सायड रोटेट जाला पळय, दॅट इज कॉल्ड एज द सिस डी आयझोमर, एंड लेफ्ट सायड रोटेट जाला पळय, दॅट इज कॉल्ड एज सिस एल आयझोमर. बेसिकली हे डी आणि एल आसा पळय, दिस इज लेटिंग अस नो दॅट इट इज डेक्स्ट्रो रोटेटरी और इट इज लेवो रोटेटरी. ओके, so that is about the isomerism we are having, because it is having effective atomic number. We have to calculate this. You can just read it out, effective atomic number, which I'm not expecting, so I'm not going with this effective atomic number. It might come, but I am not expecting, so I don't have very much interest in this particular topic as of now. So I'm moving on to the next PDF. Okay, next PDF we are having isomerism dale. Now we are having directly, we are moving towards VBT. Okay, who wanted VBT? Finally we are getting VBT. Yes, Augustine, this will not come. Yeah, can you once do VBT? Yes, Alvina Fernandez, I am doing VBT now. Yes, 198 likes मरे. Chill. 200 केले मरे तुम्ही, 300 सांगपाले तुमका, 300 बी करताले तुम्ही. I know you, I trust you. पण थोडे आसा ते मागीर लाईक काडटा आपले, तांका दाखयता राव. कळना म्हाका फक्त कोणते. आरुष मातशें चौकशी करा. Okay, so next we are having bonding theories in coordination compound. That is okay, this is a very in-depth detail what we are having, blah 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 blah, but we are getting the blue shade तेवे आमका नाका. We are directly postulates. एक करा तुम्ही, postulates करा, very important. It can come for 2 marks. Postulates of Werner theories or postulates करून चला. Directly I'm moving towards the VBT. खंय आहा ते VBT आमचे मातशे डिटेल नाका तुमका, ते डिटेल आतां शिकोवपाक खंय टायम आहा. Yeah, valence bond theory. Okay, so valence bond theory, what is the meaning of valence bond theory? Valence bond theory म्हटल्यार की आम्ही basically it was proposed by whom that we should know. It is falling in the 1930s. That is okay. It is using the hybridization ideas. Meaning कितें असता की एक आमच्याकडे एक metal असता. Now this particular metal is usually from the D block, usually the D block, and the D block कितें असता, variation or variable oxidation states असता. Now this particular D block element जो असता पळय, this element is having a oxidation state, and that element is able to, because of the variable oxidation state, it will form many complexes. आम्ही इथे पहिलीत it will form many complexes. And how it is forming complexes? It is forming complexes not by just कितें म्हणटा variable oxidation state, but because it can also undergo variable it can undergo the hybridization process. So hybridization जाता हांगा 3 स्टेपान जाता आमचे VBT. फर्स्ट स्टेप असता आमकां कंपाउंड कितें ते खबर आसपाक जाय, ते सारके दाखयता तुमकां. सेकंड स्टेप असता दॅट वी शूड नो दॅट वॉट इज द ऑक्सिडेशन स्टेट इट इज एक्झिबिटिंग इन दॅट कंपाउंड, ते आमी फायंड करपा जाय. एंड थर्डली वी शूड नो दॅट कशें बॉन्डिंग जातले, आनी जर हांगा बॉन्डिंग जाले, then what is the how many numbers of unpaired electrons are there. Based on that magnetic character identify करू शकता. unpaired electron असा diamagnetism, paired electron असा diamagnetism, unpaired electron असा paramagnetism. Okay, हे दोनच कंडिशन आमकां विचारता एग्जामीक. And in last condition कितें आसता, that they are asking us what is the geometry of this particular hybridization and geometry. So based on hybridization शिकपाचे. hybridization चे आमकां खबर आसता की what is the geometry. Okay, so that we will be doing now. So assumption of valence bond theory, the central metal atom ligands है blah 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 blah. Okay, हे सगळे blah 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 असा इतले खबर आसता. कोऑर्डिनेशन नंबरचे हे तुम्ही शिकून चला. दॅट कोऑर्डिनेशन नंबर जर 2 असा, then it is geometry किती असतली, linear or diagonal असतली. Coordination number 3 असा, then it will be having trigonal planar or trigonal planar, equilateral triangular very rare they will ask. 4 असा त्याला square planar, 4 परत square planar, 4 परत tetrahedral, 5 असा त्याला trigonal bipyramidal. पय हांगा जे कंपाऊंड दिला भावानू आणि बहिणीनू, हांगा जे कंपाऊंड दिलेले असा पय, फोटो मारून घेता, फोटो मारून घ्या, स्क्रीनशॉट बिनशॉट किती घेता घ्या, आय डोंट केअर. हे जे कंपाऊंड असा पय, these compounds only will be asked in your exam mostly. So हे जर तुमका खबर असा जाल्यार तुमका सगळे खबर असा. कोऑर्डिनेशन नंबर 5, 5 म्हटल्यार पय हांगा सकल असता 5, कितले फावटी असा तो 5 असा. इट कॅन बी FeCO5 or it can be FeCuCl5. Cl5 म्हटल्यार क्लोरीन 5 फावटी हेच्या वांगडा बॉन्ड केलेलो असा. कोऑर्डिनेशन नंबर, दॅट कोऑर्डिनेशन वी हॅव टू लुक. 4 4 पय 4 4 4 असा जाल्यार डायरेक्ट खंयची ज्योमेट्री, स्क्वेअर प्लॅनार. हे 4 असा जाल्यार this particular compound, that is nickel Cl, copper cyano, then we are having nickel carbon monoxide. हे असा जाल्यार tetrahedral, but if these are there, then it is square planar. Then if you are moving towards the trigonal bipyramidal, then this particular compounds, if you are getting the trigonal bipyramidal for what? 5, coordination number 5. 5 मागीर हांगा 6 असा. 6 खातीर we are getting 2 types, very 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 important. Octahedral VBT for the reducing the VBT for octahedral complex and writing the geometry tumka etle, that is the geometry you will be getting. What you will be getting? Octahedral, but you will be getting which octahedral, inner octahedral complex or outer octahedral complex. That depends on what type of compound we are using. If you are using the water cyanide, then you are getting inner orbital complex. If you are using NO2 and if you are using the F6, then we are getting the outer orbital complex. Okay, so that will be looking at how it is being formed. So geometry of 6 coordinated complex ions, we will go very detailed in this. In all these complex ions, the coordination number of central metal atom or ion is 6, and hence this complex has octahedral geometry. कोणाक खबर ना तेंका कळटले की 6 नंबर असा coordination number, that's why आम्ही तेका octahedral म्हणता. This octahedral geometry arises due to D2sp3 or sp3d2. Hybridization दोनच असता in octahedral. D2sp3 or sp3d2. D2sp3 is inner and sp3d2 is the outer octahedral complex. Okay. आता of the central metal atom, the number of unpaired electrons measured by the magnetic behavior of compound determines which d orbitals are used. So what are basically आम्ही जे central metal atom or ion use करता पय तेजेर असता की आमका D2sp3 मेळटले की sp3d2 मेळटले. That I will show you how it is. Octahedral complexes in which the central metal atom is D2sp3 hybridized called the inner orbital complex, while the octahedral complex in which the central atom is sp3d2 hybridized are called as outer. म्हटला की ते D जर भितर असा inner, D2 भितर असा न्ही तर पहिली येता भितर, so it is D2sp3, and D2 जर बाहेर असा then it is called as outer octahedral complex. Okay, fine. कोणाक रे कोण किती करता? The one who is watching this shitty one shot, विजय कुमार मिश्रा. अबे एड्रेस बोल बापू के, कहाँ को पेटाऊंगा नहीं मालूम पड़ेगा नहीं, कब आके बजा के जाऊंगा तुम्हारी, समझा? शिटी वन शॉट अपने बाप को बोल. बापू का सिद्धांत बॉब मारतलो असे उलयता म्हणून. Fine. Okay, I control guys. Fine. Okay, so magir kiti asa, we are having this, it may have either 1 or 5 unpaired electrons in complexes with 1 unpaired. Okay, the ligands are force metal te soda directly आम्ही आता move जाया, and we are looking at a hybridization in this one. So please pay attention how this is actually happening. Inner आणि outer कसे जाता ते तुमका खबर असपा जाय. If you are looking at if you are looking at the inner one, then हांगा पय आमचेकडे जेन्ना आमी हायब्रिडाइज करता पय usually we are using, and आमकां मरे चडशे अशें येता 3D 4S 4P आणि 4D. आता पय जेन्ना आमी octahedral complex आमी पयता, then you know that it is the coordination number कितलो आसा, 6 आसा. Then we are getting octahedral. Okay, so coordination number of octahedral मेळटा. आता octahedral I can get for two things, I can get for inner and I can get for outer. आता जर माझ्याकडे एक ion असा, and that particular ion I am getting is basically it is having 3D 4S 4P आणि 4D. okay, हे करू शकता, or else I can write 3D 4S 4P and 4D परत. But the thing is आता खंयचे हांव ऍड करतलो इफ आय एम युजिंग माय 3D पयली बिफोर द sp3 meaning this is getting filled and this is participating हे पार्टिसिपेट जाता पळय आता हांगा तुम्ही पळोवंक शकता हे आसा ते इनर ओके हे इनर गेले दिस इज नॉट पार्टिसिपेटिंग बट these two orbitals are participating and it is participating these two so d2 d चे दोन पार्टिसिपेट करता आणि s चो एक करता आणि p चे तीन करता ओके sp3 so d2 sp3 आमका मेळटा whenever this particular inner orbital is participating in the octahedral complex but if we are talking about another complex wherein हांगा सगळे एक एक इलेक्ट्रॉन असे completely filled असता and this is not getting hybridized म्हटल्यार एक्साइट करून हांगा घेना म्हटल्यार हांगा घेऊ शकता पळय हो हांगा घेऊ शकता so it will here हो हांगा घेऊ शकता it will here and this can come and this will be alone मागीर आमका हे दोन मेळटा but it is not doing because it wants to show the paramagnetism एका पॅरामॅग्नेटिझम दाखवपा जाय एका जर पॅरामॅग्नेटिझम दाखवपा जाय then it will keep its unpaired electron असेच आणि तो म्हणता की I am not taking any one of you so you just go with the other ones so आम्ही किती करता ओके we are starting with sp3 हांगातल्यान स्टार्ट करता आम्ही sp3 आणि भायले जे आउटर असा not from the inner complex we are taking the d orbital from the outer complex and we are making this hybridization that's why it is called as 1s आणि ह्यांगा p3 असा आणि ह्यांगा d2 असा that's why this is called as the sp3 d2 hybridization complex of the octahedral and this is for the inner now आता खंयचे examples असा which particular examples are showing the inner which particular examples are showing the outer complexes that also will be looking now d2 hybridization in inner orbital octahedral complex now you look at this particular three examples and you tell me what is basically observable in this first thing the iron asa आणि आमच्याकडे हांगा सायनाइड असा अमोनिया असा आणि NO2 असा सायनाइड अमोनिया NO2 these three only I am expecting in your paper if they ask to deduce the VBT for octahedral complex for octahedral and हे जर तुमका दिस मेळे नी हे तिनातले म्हटल्यार हांगा कितें आसू रे हांगा कितें आसू हो कितें आसू but these things cyanide ammonia NO2 आणि हे नंबर 6 असपा जाय नंबर 6 म्हटल्यार it is octahedral these three if you are expecting if you are looking in a paper directly आणि हांगा स पळयता तुम्ही आणि हांगा NH3 नाल्ले cyanide or NO2 पळयता directly that this is the inner octahedral complex is this clear so आता ते कशे करता तुम्ही हांगा पळयात आता now how we are doing very easy it is what we have to do okay तुमका आता cyanide if they are doing then we are taking the oxidation खंयचे केला त्यांनी cobalt चे केला cobalt and which one they have done let me tell you cobalt NO2 6 okay so they have done for this one please pay attention ki कशे केला ते सारखे over here so if we are looking we are doing for this one cobalt so first किती करता पहिली आम्ही cobalt घेता आणि त्याचे आम्ही इलेक्ट्रॉनिक configuration बरयता that is the first thing we are taking cobalt and we are writing the electronic configuration for cobalt okay next thing what we are doing is that we are writing now this cobalt is in the ground state okay ground state म्हटल्यार त्याचे कायच इलेक्ट्रॉन लॉस ना किदे ना what is the atomic number of cobalt what is the atomic number of cobalt please tell me Tanmay you can watch the previous videos part 2 and part 3 for important reactions yes please tell me what is the oxidation number what is not oxidation what is the atomic number of cobalt begin 27 okay तो cobalt आता हांगा करून दाखयता तुमका cobalt आमचेकडे we are having cobalt in the ground state so it is having the atomic number of 27 so if I want to write the electronic configuration then I am writing here argon 3d 4s ते दोन झाले 4s गेले then it will be 3d 3d 5 so 18 19 20 so 4s2 19 20 and here it will be 3d 7 okay now this is the electronic configuration in the cobalt so it is the ground state अशे बरोवपा जाय then you are writing the cobalt 3 plus ion cobalt 3 plus म्हटल्यार हांगाच्यान म्हाका तीन इलेक्ट्रॉन लॉस करपा जाय so दोन इलेक्ट्रॉन हेजे गेले and one electron from this will be lost so basically I am writing the electronic configuration like this I am writing argon तुम्ही argon बरे आता हांगा दिवंक ना you write argon 3d 6 4s0 4p0 हे ना बरयल्या जाता but 3d6 you have to write it मागीर जशे बरयला पळय तशेच ऑर्बिटल्स काढपाचे आता ऑर्बिटल्स कशे काढतले जशे तुवें बरयला फॉर द ग्राउंड स्टेट यू हॅव रिटन that it is 3d7 4s2. So तो orbitals बी तसेच काढपाचे आहेत. पहिली d orbital काढ, ओके, मागीर एक s orbital काढ आणि मागीर एक p orbital काढ, ओके, s orbital, p orbital, and you are drawing it for the p orbital, because this is the inner complex. We know that it is the inner complex, cyanide, NH3 and A. It is inner complex, so आम्ही असे करतलो. So आम्ही करतलो d orbital, d orbital, d orbital, okay, d orbital. So this is the 3d orbital, this is the 4s, and this is the 4p, okay. 4p चे कितले 3. Now here what I am doing, 3d7 मरे पहिली 4s घालया, पहिली 4s येता, सो पहिली 4s घालया, 4s2 डायरेक्ट घातले आम्ही. 3d7 म्हटल्यार 1 2 3 4 5 6 आणि 7, like this it is in the ground state. Can you see here? It is like this in the ground state. But जेन्ना तो एक्साइट जाता पळय तेजे 3 इलेक्ट्रॉन वता, सो 3 इलेक्ट्रॉन वयता म्हटल्यार कितें करपाचें, म्हाका आयन काडपाचें अशें, मागीर परत हांगा अशें 5 काडले, हांगा आयन काडले 1, and here I am drawing again the 3, and when I am drawing this, आता गेले मरे, because it is in the excited state. Which excited state? Because म्हाका हांगा ऑक्सिडेशन नंबर फाइंड करपाक जाय पयली, सगळ्यांनी पयली ते when I am finding this, I am finding oxidation number. I am getting the oxidation number for +3. Now I am getting the +3 oxidation state म्हटल्यार 3 इलेक्ट्रॉन्स म्हाका काडपाक जाय, हेचे 2 काडले आणि हांगाचो 1 काडलो. So I am writing here 1 2 अशें आसा तशेंच बरोवया, here, and I am removing, okay, I'm removing this one. Okay, I will be removing this particular double. Okay, हे असे उरतले आणि हांगाचो जो एक इलेक्ट्रॉन आसा पळय, that I will remove. I cannot remove this. I have to जशे घालता तशे काडपाक जाय आमकां. घालताना अशे घालता न्ही, 1 2 3 4 5 6 7, मागीर काडटाना बी 7वो इलेक्ट्रॉन पयली येतलो. सो पयली 2 काडले आणि हांगाचे 1 काडलो. So then it is like this. Okay, here 2 are there, here 1 and here there are nothing. Now what I am doing, now I am looking at the 6 number, and based on that what I am writing, that now the formation of this complex is being happening. Formation of this complex म्हटल्यार nitrate जे आसा पळय, there is so molecules आसा that will occupy the 6 stage, like 6 stages over here. Now how this will be occupying the 6 stages, म्हाका पळय भायलो कॉम्प्लेक्स करपाचो ना, because म्हाका खबर आसा नायट्रेट आसा, अमोनिया आसा आणि सायनाइड आसा. It will form the inner complex. So what I'll be doing, I will be making this particular जे इलेक्ट्रॉन आसा पळय तेंका पेअर करितलो. पेअर करून हे म्हाका 2 बॉक्स खाली करपाक जाय, कशेय करून 2 boxes I am making it empty. So हे जेन्ना म्हाका 2 box empty केन्ना करपाक मेळटले, when I will be exciting this electron and I will be exciting this electron, एका दोनाक काडटलो आणि हांगा घालतलो. सो हेंका काडटा, एका हांगा घालता, हे जो काडटा हांगा घालता. आता कितें जालें, आता माझे कडेन हांगा इलेक्ट्रॉन्स ना, it is empty. Now this particular orbital can undergo hybridization, because माझ्याकडे 6 boxes empty आसा, 1 2 3 4 5 6, आणि आमचेकडे नायट्रेट कितले आसा, it is also 6. Now every nitrate will put 2 of its electrons. अशें घालतलो, हे लास्टाक बरोवता, नेक्स्ट स्टेपान बरोवपाचे तुम्ही, पळय अशें बरोवपाचे. नेक्स्ट स्टेपान 2 घातले, हांगा 2 हांगा 2 आणि हांगा 2. यू कॅन, इफ यू वॉन्ट, यू कॅन, कशें करता रे तेशी, ते चोडवांक बरें जाता करपाक, मेहंदी काढता तेंका. You can do it like this, अशें करून you can do it, and you can write that 6 molecules of NO2 hybridizing this orbit, and it is showing which hybridization. A D mare, this is 3D, this is 4s, and this is 4p. So 3D, so D कितले आसा 2, D2, S, and P3. So this is showing sp3 hybridization, sp3 hybrid, and complex किती D2sp3. So inner octahedral complex ते कळ्ळें आमकां, geometry कळ्ळी आमकां. आता based on geometry, now I will tell, आता हांगा magnetic behavior किती आसा. magnetic behavior केन्ना आसता, जेन्ना हांगा unpaired electrons आसा पळय, हेका म्हणटा unpaired, paired ना, then it shows paramagnetic behavior. But as it is having all paired electrons, everywhere it is paired electrons, पळय एकलो ना, okay, it cannot show any कितें म्हणटा magnetic behavior, because सगळे paired आसा, meaning it will be showing dimagnetism. Is this clear? Next one is for sp3d2. Now if you look at the, if you are getting a coordination number which is having 6, but you are getting fluorine, अशे fluorine मेळटा, मोस्टली जे octahedral outer complex असता पळय, outer complex in VBT, they are usually having these fluoride ions, what I am expecting in your paper also. Okay, so कोण रे? रोहन भुटिया, देविका आय लव्ह यू. आमकां काय सांगता तर? ताका सांग मरे, गट्स ना तुका सांगपा ताका. ताका सांग, त्याच्या आवय बापायक सांग. शेल. हांवें सांगलेलें. मार पडले ते दुसऱ्या. Okay, so we are having this FeF6, COF6 आणि हेच compound ना, these only compounds I'm talking about. हेच repeat जाऊ शकता. Directly they will give you deduce the VBT for this particular coordination compound and write what is the hybridization and write what is the magnetic moment of this particular thing. Okay, so or they will ask how many unpaired electrons are there in this one. Unpaired अशें मागीर तुम्ही बरोवप की कितले unpaired आसा ते तुमकां दाखयता आता next. So same thing you have to follow. Same thing, first thing ion घेतला आमी. आता ते करच्या पयली first thing what you have to do, because आमचो compound कितें आसा, look at the compound, they have taken this. So this particular compound if we want, then first we have to find the oxidation state of this. Now fluoride is showing -1, so it is having -6. X minus 6 is equal to -3, so X is equal to -3 plus 6, so X is equal to +3. We are getting +3 oxidation state in this particular compound. Okay, +3 oxidation state मेळ्ळा आमकां. आता +3 oxidation state मेळ्ळा पळय, we have to write the electronic configuration in the ground state first. Step by step. First step कितें? First step is to find the oxidation state. Second step is to write the electronic configuration in ground state, and third step is to write the electronic configuration in excited state. Okay, and along with ground electronic configuration you have to draw the orbitals also. Draw the orbitals also. And we are doing, because this is the outer complex, so we'll be doing the outer one also. So this is will be the 3D, this is the 4S, this is the 4P, and this will be the 4D. Okay, because we know that fluoride is forming outer complexes for octahedral. So excited बरेल अशे हेचे काडपाचे same thing. Now they have written for the ground state. हांगा बरेल तेंच्यानी हे तेंचे boxes आता. Okay, these are the boxes. These diagrams I have taken from Google. म्हाका माझे काढले, मागीर तुका हँडरायटिंग करचीत ना. हे घातला, and this is basically the outer one, because inner one is eventually not participating. Okay, now we are having this particular over here, this is empty. Now Fe ion in hybridized state, so we are getting here. आता बघिये आता when I am removing these 2 electrons, because it is Fe +3, no, +3 म्हटल्यार हांगाचे 2 इलेक्ट्रॉन्स गेले आणि हांगाचो तो 1 इलेक्ट्रॉन असलो तो गेलो. आता हे सगळे पळय, हे सगळे एकटे झाले. There is no one which is having any paired, so it is alone in the 3D. So what will happen? These people will tell that आम्ही एकटे okay asa, we don't want anyone else to come and bond with us, because पळय एका जर मी excite करपा वयता, जर मी एका excite करपा वयता, then I am exciting this one, no, so it is coming here. If I'm exciting this one, then it is coming here. If I'm exciting this one, then it is coming here. पण हो एकटो उरता मरे, हो एकटो उरता म्हणून ते कितें सांगता, आमकां आमचे भावाक सिंगल दवरपाचे ना. If we are getting married, then we will let our brother also to get married. Okay, meaning ताका बी सुख दिवपा जाय. सो हे म्हणटा जर तो सुखी ना जाल्यार आमकां बी सुख नाका. कळ्ळें तुमकां? त्या खातीर हांगा ते जायना. क्लियर? कळ्ळें मरे? ओके, त्या खातीर आउटर कॉम्प्लेक्सेस अशे फॉर्म जाता, बिकॉज दे वॉन्ट एवरीवन टू बी सुखी. हो सुखी आसना म्हणून जायना. नाव that's why they start forming another extra orbital which is coming from the D. अब एक और D चे orbital आता हांगा काढला तेंच्यानी 1 2 3 4, सो 5 आसा, इट इज 4D. सो तो कितें म्हणटा की तुम्ही चला थंय वचा आनी आपले कितें ते करता ते करा, हांगा आमचे फुडें करना, आमकां बरें दिसना. सो ते मागीर हांगा हांकां भायर धाडटा आनी मागीर तो म्हणटा की ओके आमी हांगा आसा, आमी अशेंच रावया. पूण हांगा जे आसा पळय तो मागीर येता. कोण येता? फ्लोरायड येता. ओके, F6 येता. तो म्हणटा की आपूण आता सगळ्यांचे लग्न करून दितलो म्हणटा तो पॉश अंबानी. तो मागीर हांगा कितें करता, आपले 2 इलेक्ट्रॉन हांगा घालता, आपले 2 इलेक्ट्रॉन हांगा घालता, आपले 2 2 2 2 2 2 2 2 2 2 2 2 2 2 घालून हांगा फुल तो एक हायब्रिडाइज कॉम्प्लेक्स फॉर्म करता. हो असा S, these three are for P3 and these two are for D2. सो आमकां हायब्रिडायझेशन मेळटा sp3d2. भायले लोकांक हाडले न्ही अंबानी, ओके, भितरले लोकांक मोरोनी म्हणटा तो. सो भायले करता and the geometry is octahedral outer geometry. आता क्वेश्चन येता, what is the magnetic moment of magnetism? The magnetism is paramagnetic. Why? Because unpaired electrons they are weakly attracted towards magnetic field. Paramagnetic. And kitle unpaired electrons are 1, 2, 3, 4, 5. Number of unpaired electrons you have to write. Number of unpaired electron you have to write. It is 5. Zale, sople. Okay. Faltu. Sir, say something I don't know. रोहन भूटिया, आप देविका से प्यार करते हो तो आप डेयरिंग करके उसको जाके बोलो. ठीक है भाई, करो सब लोग. आप पढ़ाई करते हो तो पहले पढ़ाई करो, प्यार बाद में हो सकता है, पढ़ाई बाद में नहीं होगी, पढ़ाई बाद में करने मुश्किल होता है. ओके, ऑल द बेस्ट विद देविका एंड पढ़ाई, ऑल द बेस्ट. हमको खुशी है कि आपको प्यार हुआ है. हम प्यार करने वाले लोगों से भी प्यार करता है. कि फालतू मंदिर है, समझा ना? आपको फीलिंग पे जाओ, वर्ड्स पे मत जाओ. हमारा थोड़ा ये है. ओके, सो अंडरस्टूड नाउ व्हाट इज बेसिकली हाउ वी आर डूइंग व्हीबीटी कशें करता कळ्ळें मरे? कोणाक कळोंक ना व्हीबीटी सांगा म्हाका आता. हे फालतू मरे व्हीबीटी कितले स्टेपान करपाचे? 4 स्टेपान व्हीबीटी जाता. तुमकां सांगला. फर्स्ट स्टेप इज फाइंडिंग द ऑक्सिडेशन नंबर ऑफ द कंपाउंड. Second step is writing the ground state and drawing the orbitals. Third step is writing the excited state and drawing the orbitals. Fourth step is making the electrons जर जाता जाल्यार पळोवपाचे लग्न करून. सगळे सुखी आ जाल्यार, सगळे सुखी ना जाल्यार तांकां हात लावप ना, ते मागीर दुखी जाता. ओके, सो सगळे सुखी आ जाल्यार तांकां वाइंड अप करप आनी सगळे सुखी करप. सगळे सुखी ना जाल्यार ओगी तोंड आपलो घेवन फुडें वचप आनी फुडें मागीर वचप. मागीर थंय मागीर आमी कॉम्प्लेक्स जेन्ना फोर्थ स्टेप इज फॉर्मिंग द कॉम्प्लेक्स ऑफ द एनी कंपाउंड. स मॉलिक्यूल दिला, 4 मॉलिक्यूल दिला, 2 2 2 2 करून 4 ऑर्बिटल फिल करप. जितले ऑर्बिटल हायब्रिडाइज जाता तांकां वांगडा करून सकल बरोवप की इट इज व्हॉट टाइप ऑफ हायब्रिडायझेशन काउंटिंग द ऑर्बिटल. आणि बेस्ड ऑन हायब्रिडायझेशन तुमकां ऑलरेडी हांवें सांगला की खंयचे आमकां जॉमेट्री मेळटा ते वयले टेबलान. फोटो मारून घेतला मरे, तेच जाले, सोंपले, पावले तुमी स्वर्गान. ओके, येस. सर कोण रे तो घाटी? ए तू देविका, ओय ओय तुका म्हणोंक ना दिसता ते, तरी कोणी दुसऱ्यांक म्हणला दिसता, म्हाका खबर ना. हांगा देविका आसा मरे. माय गॉड हांव समजता तो आपले देविका म्हणटा म्हणून. शिट मॅन. आवय गे, शी. देविका तुका म्हणूंक ना ना, म्हाका खबर सुद्धा ना की देविका आसा म्हणून हांगा. आय डोंट नो. ओके, तू कंप्लेंट कर तेजी. ओके, आय डोंट लाईक हिम म्हणून सांग. देविका. येस, व्हीबीटी कॅन आस्क इन ऑप्शन्स. ऑप्शन्स कशे सांगता? ऑप्शन्स बी येता. ऑप्शन्स म्हटल्यार एमसीक्यू सांग कितें विचारता की दे आर गिविंग अ पर्टिक्युलर कंपाउंड एंड डायरेक्टली आस्किंग यू विच पर्टिक्युलर हायब्रिडायझेशन इट इज एक्झिबिटिंग. सो जस्ट लुकिंग एट द कोऑर्डिनेशन नंबर क्या रे तुम लोग मरे, तुम लोग ऐसा एका कितें जालें? चल मरे वयर बाबा. हय, क्वेश्चन अशें येतले एमसीक्यू बेस्ड ऑन कोऑर्डिनेशन नंबर अशें दितले की अशें कंपाउंड दितले एंड दिस कंपाउंड इज हॅविंग द 2 नो कोऑर्डिनेशन नंबर. कसली जॉमेट्री बाय? लिनियर. मागीर हांगा दितले खंय कंपाउंड दितले 4 कोऑर्डिनेशन नंबर. कसली जॉमेट्री? ओके, स्क्वेअर प्लेनर. मागीर दितले 4 आनी एक आसा पूण कसली जॉमेट्री? बेस्ड ऑन द टाइप ऑफ मॉलिक्यूल इट इज. इफ इट इज फॉर्मिंग विथ निकल एंड इट इज क्लोरीन देन यू हॅव टू स्टडी दीज 3. ओके, अशें आसा जाल्यार देन इट इज टेट्राहेड्रल. सो हे स्टडी कर म्हणून सांगला हांवें. हेजेर एमसीक्यू येता येल्यार coordination number चे, or they will ask you giving the coordination number 5 what geometry it is exhibiting. You can write by trigonal, by pyramidal, but the thing is coordination number 5 is exhibiting 2 types of geometry. So this asking this particular question in MCQ is very like ambiguous matla the question can have 2 answers, 2 meanings, so they will not ask. Yeah, Devika be like, what is happening? देविका चाव घेवपाक गेल्ले दिसता. सामके हे जाले तेजे, तकली उडयली तेणी. सुखी ना म्हटल्यार वीक फील्ड. येस, सुखी ना म्हटल्यार वीक फील्ड. अँड सुकी आसा म्हळ्यार स्ट्रॉंग फील्ड. ओके, ते तरी बी सगळे दिलेले आसा. ओके, प्लीज प्रॅक्टीस these things in VBT. स्ट्रॉंग फील्ड, वीक फील्ड, octahedral, inner octahedral, outer octahedral, coordination number कशे असता, coordination नंबरा बेस्ड ज्योमेट्री कितें असता, एंड ज्योमेट्री आसा जाल्यार आमकां मागीर ओके मागीर जे हायब्रिडायझेशन जाता कसले हायब्रिडायझेशन जाता, एंड द लास्ट थिंग इज की आमचे मॅग्नेटिक बिहेवियर कितें असता. फुल भरलेले आसा ऑर्बिटल सगळे सुकी आसा, देन इट इज डायमॅग्नेटिक. आणि एक सुद्धा बावडो एकटो, दोग जाण, 5 जाण, 3 जाण जर एकटे आसा आणि ते सुखी ना लायफान, जाल्यार ते कितें करतले? ते कितें करतले? एकटो मनीस कितें करता? अट्रॅक्ट करता न्ही लोकांक. पूण ऑलरेडी लग्न जालें जाल्यार ते म्हणटले यो म्हणून ना. ते आर ऑलरेडी लायक दे आर इन टेन्शन न्हू, आनी नाका म्हणटा ते. पूण एकटो आसा जाल्यार तेका खबरूच ना टेन्शन कितें, सो इट वील ट्राय टू अट्रॅक्ट. ओके, दॅट इज कॉल्ड एज पॅरामॅग्नेटिझम. एकटो आसा, अनपॅड इलेक्ट्रॉन्स आसा म्हटल्यार तेंचे लग्न करपा जाय, सो दे वील अट्रॅक्ट इन द मॅग्नेटिक फील्ड, पॅरामॅग्नेटिझम. ते मागीर पयलींच लग्न जाल्लेले आसा, इलेक्ट्रॉन्स पॅड आसा, देन इट विल नॉट अट्रॅक्ट, दिस इज कॉल्ड डायमॅग्नेटिझम. ओके, येस 215 जाले मरे, लायक व्हेरी गुड. 200 करुया, 250 करून या. ओके, 250 तर जायच मरे आमकां, कितें रे, नाल्यार लज जातले मरे आमची. 250 जाय, सो मातशें एक लास्ट उरला ते करुया. 8 सोंपया लायफ. ओके, बट बाय 8 यू वील ट्राय दॅट यू कॉल युअर ऑल द गर्लफ्रेंड्स, बॉयफ्रेंड्स म्हटल्यार फ्रेंड्स आनी तांकां आपोवन लायक करपा लाया व्हिडिओ. सो ज्योमेट्री जाले, ज्योमेट्री आनी काय चड उलयना, बिकॉज आय डोंट वॉन्ट टू मेक कन्फ्युज. तुम्ही हे पळयात हे पीडीएफ. आय विल अपलोड दीस, आय हॅव नॉट अपलोडेड आय गेस. या 4 कोऑर्डिनेटेड, मागीर पळय स्क्वेअर प्लेनार, हे सगळे ज्योमेट्रीज आसा. ओके, सो दीज थिंग्स यू कॅन जस्ट डू इट, इट इज डन. आनी तुमकां चड दिवन कितें आबूज करिना, इतले तुमकां सांगला तितले तुमी करपाचे. ओके, लास्ट कितें पीडीएफ आहलो मरे तो, लास्ट एकूच पीडीएफ आहा तो, सोंपलें. मागीर ते पीडीएफान फक्त डिस्कशन आसा. मागीर आय विल डिस्कस विथ यू डायरेक्टली ऑन दी कॅमेरा कितें आसा जाल्यार. अशें ब्लॅकान बॅकग्राउंडान बरें दिसता मरे, ते धवे धवे सामके तोंडा मारता. खंय रे बिबिडे खंय तो एक पीडीएफ केल्लो हांवें तो लास्ट, खंय खंय तरी फायनल पीडीएफ क्यूएनए होच दिसता मरे. फायनल क्यूएनए पीडीएफ करपाकूच जाय, दिला ते करपाकूच जाय. ओके, सो फक्त दाखयतलो, काय करचो ना, फक्त दाखयता तुमकां, सो दॅट यू कॅन जस्ट डू इट. ओके, सो सेक्शन 1 इज फॉर कोऑर्डिनेशन कंपाउंड. हे आत्ता गेला बसून हांवें सारखे युटिलायज करून. सो इट इज आस्क फॉर VBT हायब्रिडायझेशन, ज्योमेट्री एंड मॅग्नेटिक कॅरेक्टर, हाय स्पिन ऑक्टाहेड्रल कॉम्प्लेक्स. वाय CO F6, आय टोल्ड यू हाय स्पिन मॅग्नेटिक F6 मरे पळय, F6 आणि कोबाल्ट. F6 म्हटल्यार कितें, इट इज शोइंग ऑक्टाहेड्रल, बट व्हॉट ऑक्टाहेड्रल? आउटर octahedral complex. It can be asked for VBT mostly. हेच विचारता जर ते विचारले जाल्यार फॉर octahedral. Then we are having nickel cobalt 4. Ask for VBT also. Magnetic nature दाखयले, magnetic nature तुमकां सांगले हांवें. अनपेड इलेक्ट्रॉन आसा, पॅरामॅग्नेटिक, पेड इलेक्ट्रॉन आसा, डायमॅग्नेटिक. जाले, सोंपले गाइस. ओके, मागीर FeCN6 सेम थिंग, इनर ऑर्बिटल कॉम्प्लेक्स. वाय इनर ऑर्बिटल? सायनाइड आसा. It is not fluoride, cyanide asa inner orbital complex. Which hybridization it will show? It will show D2sp3 inner. And what type of magnetic behavior it will show? It will show diamagnetism. Okay, because सगळे paired असतले. लो स्पिन बिहेवियर सगळे ते D2sp3 सगळे पय chill झाले. हे केले की पावले स्वर्गान फॉर द VBT and all. Okay, CR3 NO2 से ask for oxidation state and coordination number calculation. Coordination number calculate करपा जाय हांगा, कितले आसा ते बॉन्ड केलेले. मागीर FeNH3 ज्योमेट्रिकल आयझोमेरिझम, कसलो आयझोमेरिझम दाखवू शकता हांगा. ओके, इट कॅन शो बेसिकली. ओके, तुम्हीच सांगा म्हाका कसले आयझोमेरिझम दाखवू शकता. FeNH3 twice and CN4, it can show linkage isomerism because CN can be written also as NC. Okay, so it is ambidentate. Then we are having this optical isomerism hanga oxalo, this is a polydentate. Then we are having all these things, nomenclature सगळे आसा. मागीर हे आसा कंपाउंड, जे कंपाउंड हांगा दिला पळय ते कंपाउंड तुमचे जावपाकूच जाय. इफ यू आर नॉट डुईंग इट देन लेटर ऑन डोंट टेल मी दॅट क्वेश्चन येयल्ले पण आमी करपा विसरले. आय डिडंट टेक यू सिरियसली सर. म्हाका मागीर मेसेज करता भुरगीं की आय डिडंट टेक यू सिरियसली, आय डीड वॉट माय टीचर टोल्ड मी, आनी तेणी सगळे आमकां डिफिकल्ट दिल्ले, पूण तुवें दिल्ले तेच येयले. तशें नाका, आता करा न्ही, सारखे करा. ओके, दो बोट में, बोट मतलब बोट रे, न्हंयन घालता ती. दोन बोटान मरे तुम्ही पाय धरून पावू शकना, पिंतले. एकच बोटान चला आणि एक बोट सारखे युटिलाइज करा. रोहन भुटिया, ठीक है तुम पढ़ो मैं जा रहा हूं. ठीक है भाई, आराम से जाओ. ओके, आप भी पढ़ो. ऑल द बेस्ट. Okay, VBT most likely question. These are the questions what I have derived and maka dista has from this only it should come. So you do it. That is most likely questions using VBT derive hybridization for CuF3 very strong. Second, we are having Fe6 very strong repeated. Then we are having this nickel cobalt diamagnetic सगळे दिला. Distinguish between inner and outer तुमका सांगले already आहे. Predict the number of unpaired electrons ते बी सांगले आहे. कितले prediction असतले ना unpaired electrons, magnetic moment आणि octahedral सगळे. Okay. Next we are having isomerism. Isomerism किती असा geometrical isomerism. Oh, I am expecting this particular thing. FeNH3 CN geometrical isomerism. Then draw the optical isomerism of this one oxalo. Then explain the linkage isomerism with suitable example. Explain coordination isomerism with example. So coordination with example you have to explain. Define ionization isomerism and give one example. हे तुका म्हणतालो ते सल्फेट आणि क्लोरीनचे आयोनायझेशन. पहिली सल्फेट वयता मागीर दुसरे क्लोरीन वयता. So this is what I am expecting the questions. Nomenclature most likely right. IUPAC name of this one. IUPAC name येले जाल्यार म्हाका असले येल्यार बरे जातले बिकॉज कितें आसा की भुरगे न्हू सामके इजी करपाक गेल्यार जाल्यार दिस इज ऑल्सो इजी ओनली. बट द थिंग इज हियर टू अप्लाय युअर ब्रेन नो. सगळी जाण अशें करता एल्युमिनियम Cl3 सो क्लोराइड बीन बरयता पूण हांगा अशें ना. हांगा वी आर टेकिंग दिस एज अ एनाइन एंड वी आर मेकिंग इट एज एल्युमिनेट. So तशें आसा. So I am expecting like this illuminate, cobaltate, ferrate sort of questions. Okay, next write the IUPAC name of this one. ते दिला अगेन IUPAC असा ते सगळे IUPAC असा जे क्वेश्चन दिला ते तुम्ही पळयात हांगा सगळे क्वेश्चन्स. These questions I am expecting in your paper only. Okay. Next, what I am having is the section to the biomolecules likely questions. What is a peptide bond? सांगला तुमका. What is a peptide bond? What is denaturation of protein? सांगला तुमका. Mention causes बी सगळे सांगला. कित्याक जाता, कित्याक जायना, कित्याक जाता, जायना न्ही, जाता. Distinguish between starch and cellulose ते सांगला. Amylose and amylopectin एक क्वेश्चन ऐड करा. हांगा करपा विसरलो. Differentiate between amylose and amylopectin. Okay, distinguish between star and cell झाले. DNA, RNA. Explain the cyclic structure of formation of glucose. Cyclic structure of the hemiacetal ring जाता ती cyclic structure. Now it is having two structures. One is with the किती म्हणतात का आम्ही एक असा जो नॉर्मल असे दाणे दाणे कसो असा आणि एक असा पायरेनो स्ट्रक्चर म्हणता. ओके, पायरेनो स्ट्रक्चर इज हॅव्हिंग द 5 साइडेड. सो पायरेनोज असे 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 पेंटागॉन काढता आम्ही ते तो स्ट्रक्चर बी करपाचो ग्लुकोज आणि फ्रुक्टोज जावचो हा दोन्ही. So classified vitamin based on fat soluble and water soluble. ते तुमका दिला already. Differentiate essential non essential. सगळे झाले बस सगळे A to Z. What is secondary structure of protein? What is the meaning of secondary structure? मतलब how it differs from primary structure. Very important. Then we are having the DNF block. What is Lanthanoid contraction? Why is zinc salt a colorless? This question I was telling you. Why zinc Zn2 plus salt is colorless? Why is Cu2 plus salt are किती म्हणता colored? Okay, why are Zn2 plus salt colorless? Why are Cu2 plus salt colored? Very important question what I feel should come in your exam. Okay, next we are having write the complete ionic equation of chromate and dichromate. Draw the structure of chromate or dichromate. आयजूच करा. क्रोमेट आणि डायक्रोमेट करपाक चड टाइम लागना. बारीक क्रोमेट इतलो आसा, डायक्रोमेट मातसो व्हडलो जाता. क्रोमेट प्लस क्रोमेट डायक्रोमेट. ओके, सो ते जाले. मागीर आसा कितें आसा प्रेडिक्ट विच ऑफ द फॉलोइंग आयन एक्झिट मॅग्नेटिक कॅरेक्टर. हे तुमकां खबर आसा. प्रेडिक्ट विच ऑफ द फॉलोइंग आयन विल बी कलर्ड. विच विल बी हॅव्हिंग अनपेड इलेक्ट्रॉन्स. इलेक्ट्रॉन आसा जाल्यार एब्झॉर्ब जातले. एब्झॉर्ब जाले की कलर दाखयतले. वाय डू झिर्कोनियम एंड हाफनियम हॅव सिमिलर एटॉमिक रेडियाय? होत मारतो शी खंय दोळे चष्मा घालून कितें फायदो ना. दिस वन. ओके, very important 1 mark question. Okay, zirconium and hafnium, why they are having similar atomic radii. Okay, explain why actinoid contraction is greater than lanthanoid contraction. This is also a very expected question, but I will not say very important, but I feel that it is very important. But तुम्ही करा हा. Explain why actinoid contraction is greater than lanthanoid contraction. So yeah, we are done with all the things which have to be discussed. Okay, so we have to just keep in our mind. Just give me one moment. I forgot my mobile phone. Okay. इनऑर्गॅनिक झाल्या मरे इनऑर्गॅनिक बाबा हे कितें तर हे कितें केलें आमी आतां इनऑर्गॅनिक करूंक ना what is coordination compounds coming under it is coming under the mix like it is the uh, center between organic and inorganic having the d block elements also having certain organic compounds also and we have done dnf block and we have done the biomolecules also biomolecules is the organic topic so this is all done everything is done so we were talking about rest mm, 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 mm. Okay, so basically, I will tell you a very perfect answer who is asking for sir strong and weak field ligand. Okay, so I will just tell you a very perfect answer what you can understand. Mm, mm, mm. It is basically related to crystal field theory. So they if they are not asking the question which is where you have to draw it, you have to draw the crystal field splitting for the किती म्हणतात एका T2G level or T2G energy level or EG, which is the weak field ligand and the strong field ligand. So, if you're talking about the weak field ligand and strong field ligand, then we are having if the how I can put it into the words. Just let me tell you. Okay, okay. If the splitting energy of the crystal field theory is large, meaning it is having a great splitting, the splitting is occurring as a very good amount, then it is called as the strong field ligand for your understanding. If the splitting energy is small, like very least amount of energy is used in the splitting of the octahedral complex, then it is called as the weak field ligand. Okay, that you can just understand. And if you want to examples, they're going to tell you the examples of weak field ligands. We are having the examples of weak field ligand, that is the hydroxide. We are having all the halides like chlorine, bromine, fluorine, iodine, all the halides. And we are having the water, that is a neutral ligand, it is acting as a weak field ligand. Then if you're talking about the next one, strong field ligand, then we are having the compounds which are cyanide, carbonyl मतलब carbon monoxide थे, carbonyl CO, and we are having the nitro NO2, we are having NH3 ammonia, and also we are having ethylene diamine. These are strong field ligands. इथले तुमका खबर असल्यार पुरो चढ तुम्ही आता आपल्या प्रेशराइज करू नका. SN1, SN2, I have already explained, I guess, in the previous. SN1 केन्ना जाता genetic when we are basically having the tertiary when the tertiary haloalkanes असता पळय तेका आमी SN1 यूज करता tertiary conversion खातीर and when we are doing it for primary formations then we are using for SN2. Okay, computer science, I when you're having paper, just tell me when you're having paper for computer science. रोहन भूटिया सर आप पढ़ाओ मुझ पे ध्यान मत दो नहीं ठीक है 26th computer science. Okay, just Arush, just remind me on WhatsApp, please, about the computer science. I'll try to do something about it if it is possible. Because I'll have to tell someone. I have not taken computer science. No, I can teach computer science. Not a big deal. But म्हाका ते prepare करचे पडटले पयली computer science. How to teach it, like the content and all. So I will tell someone who is already into the field of computer science. so that that particular person can do justice, but I'm not promising. I'm trying my best. Okay. और क्या रे, मैं तुझे सिक्योरिटी गार्ड लग रहा हूँ? कभी हमारे मैथ बुक ओपन करना, फिर देखना कि कैसे तुम नाइट को सोते हो. हैं? किती म्हणता रे तू? किती म्हणतो? हाँ बट हिंदी राष्ट्रीय भाषा है. हाँ भाई, ओके ओके. इधर इधर ये मत करो रोहन. रोहन भाई, इधर लफड़ा नहीं करने का, चिल करने का. लफड़ा करेगा तो क्या होएगा? ओके. ओके बाय सर, गुड नाइट बाय. ए देविका. देविकाचे पाठी पडला. देविका, सामान राह तू किती. माय गॉड. येस. सायकोलॉजी परत आहे रे बा. परत अगेन. आतिफ शेख. सायकोलॉजी प्लीज. बात आणणं का? ओके. येस, एनीथिंग एल्स प्लीज लेट मी नो. आय विल बी हिअर टिल 8. ओके. मागे वयताना कितें खाता हांव. कितें केला काय खावपाक? शी, असली भूक लागल्या म्हाका. प्लीज टेल मी एनीथिंग एल्स यू आर हॅव्हिंग, देन जस्ट लेट मी नो. आणि म्हाका 250 लायक जाय हांवें सांगला. 250 लायक जाय. ओके. 250 लायक चाहिए. लायक करो, 250 करो. आणि काल भाशेन केलें न्हू, म्हाका वचोंक जाय घरा. नाटकां करनाका, पयलींच सांगता. बेगीन करा. हॉर्मोनचे कितें सांगू? हॉर्मोनचे बद्दल कितें आसा रे. आय एम नॉट एक्सपेक्टिंग एनी पर्टिक्युलर क्वेश्चन. लायक आय एम नॉट एक्सपेक्टिंग अ पर्टिक्युलर क्वेश्चन ऑफ हॉर्मोन्स. सो येल्यार जाल्यार तुमी गाळी घालतले म्हाका. सो तुमी अभ्यास करा, बट आय एम नॉट एक्सपेक्टिंग. ओके. येस, वेलकम. क्यूट ओजी. रोहन be like, Devika, oh my darling. Oh my god. Oh my god. Important. Tanishka Manjrekar. Tanishka, you can watch that particular videos. Okay, part one. Part one is physical, total physical. Part two is having the organic name reactions, and part three is having the other part, the multi-step conversions. I have explained how we can do multi-step conversions. And today is the part 4 where we have covered biomolecules, DNF block, and we have done coordination compounds, including VBT and all sort of things. Okay. So, sir, please tell something about electrochemistry. Sangla, you can watch the part one video in my video playlist, class 12 science, or you can just go to my channel and you can click on the live and you will find the video part one. Coordination on sang please. Strong khaycha and weak khaycha. Already I have told previously, so you can watch this particular video at the end, and you at the end of like two like odis wara upran तुम्ही पोहू शकता, and you can just see. I have mentioned which are weak filled, the halides and water, and which are strong filled, the cyanide, ammonia, and ethylene diamine. So again, I will not repeat. Don't ask me again, please. Yes, problems Kela part one. Just go and watch that and solve each and every problem what you have done. Okay, coordination song and what else? What else? What else? Please begin sanga maka. Tomorrow is your paper. All the best. Maka soda तुम्ही maka likes करीना दिसता अडीशे. Asu, I will close the. I will turn off the live and I will go. You also go and study. Asu अडीशे तुम्ही करीना अडीशे. हेच बरं हेच चूक मरे आता. Okay. Okay. Yes, these PDFs are available on the app. आता जे घातला, just now what I've shown. No, that again I'm uploading now. Yes, everything. Open chain structure textbook. 250 करा मरे. किती रे तुम्ही? 237, 250 लाईक्स करा आणि चला मरे. ओके, म्हाका खुश दवरले. फाल्यां तुमकां हांव तुमच्या खातीर प्रे करता. तुमकां बरे पेपर वचोनी म्हणून. आणि तुम्ही मागीर म्हाका खुश करा मरे. 250 करा. बेगीन बेगीन करा. आणि कोणाक करपाचें ना ते वयता जाल्यार चला. ओके, हांव बंद करता आनी वयता. आसूं ना केल्यार जाता. सर विदाउट दिस कशें पास जावं? टेक्स्टबुक वाच. टेक्स्टबुक वाच आणि कर. ओके. So yeah, all the best, everyone. Take care. Bye bye. I'm leaving. Okay. So बरे करा आणि म्हाका फाल्यां मागीर कोणतरी पेपर धाडा. We will do the solution also of the paper. Solution live only will do. Like total full solution करूया live of the paper. So म्हाका कोणतरी धाड. Okay, Arush, if you are sending me पेपर जातकूच सारको बरो स्कॅन कर पेपर. सारको स्कॅन नाल्यार कितें PDF करता PDF better you do PDF and send me the paper. And then I will solve the paper and then you can understand की आपणाक कितले मार्क्स पडटले आन्सर्स पळोवन कशें बरयला कितें बरयला that also we will discuss. Based on that we can estimate. सायकोलॉजी पोया गो सायकोलॉजी पार्टी पडला माझी सायकोलॉजी 242 झाले कम ऑन गाईस 8 likes more and we are leaving. कोणी ताका मेसेज केला सर इलेक्ट्रोकेमिस्ट्री विच लॉ इज इम्पॉर्टंट Kohlrausch law or Faraday's law, both you do it. Okay, Kohlrausch law of like independent migration of ions and Faraday's law of electrolysis. दोन्ही करा किती हा करपाक दोन्ही करा मरे बोथ आर इम्पॉर्टंट येले जाल्यार दोगांतलो एकतलो नाल्यार घेवचोच ना क्वेश्चन. सर पेपर लीक कर हांव कशें लीक करून पेपर शिकयला ते कर मरे जातलो आपुणूच लीक. सर तू सुपरवायझर उरता रे ना I am not supervisor. I don't teach in any school. Not interested teaching in schools. वाज येता मरे सकाळी वचपाचे मागीर डेली तेच भुरग्याचे तोंड पळोवपाचे तेच भुरग्याचे पचकेपणां आयकपाचे आनी तेच भुरग्यांक हांव बी म्हाजे पचकेपणां आयकोवपाचे नॉट गूड. मागीर ते 15-20 मिनटां येता फक्त खावपाक इंटरवल कितें म्हाका अर्दे 2 वर जाय हांव सिरीज पळयत पळयत खाता. Sir, name some very important reactions that can be asked directly. Dilan already. I cannot name very like directly important. I told you carbylamine, off-bromide degradation. Then we are having Sandmeyer's, Williamson. All these we have discussed. Ithard reaction, Woods reaction, Colby's reaction, Woods fitting reaction. करा ते ओके सर आमगे टीचर फालतू रे ते बाबा तू माझ्या चॅटान येवन टिचरांक बी फालतू म्हणना का ते माझे केस घालता मागीर कंप्लेनी घालता मागीर बेश्टे बरे पयशे वयता लॉयराक दिवपाक ते सगळे मांगडे नाका पूण मजा येता मजा येता. हय गे देविकाचे कितें जाले गायस आवय गे देविकाचे कितें सांगू तुका देविका कोण तरी येल्लो सोदपाक येल्लो देविका ताका धांवणयले आमी मागीर कितें उलयता. I wanted to sincerely request I could please get only the physics psychology notes. Psychology only psychology खया psychology आणि कितें कितें आहा सांगा रे बेगीन जालें तुमी लायक घालता आनी काडटा म्हाका म्हाका भूक लागली आहा पळय व्हॉट इज दीस 8 जाली मरे लायक करा बेगीन 250 250 लायक्स ओके 250 लायक्स करा बंद करया आमी तुमकां शिकपा नाका तुमी मरे टाइमपास रे एक नंबर आणि हे नाटकां करता पळय लायक घालता काडटा कोण करता तो पळय तो बरो शिकला आनी टाइमपास करता हांगा बसोन. सर हाऊ मच मार्क्स फॉर पासिंग तानिया कितें जीव वयता तुजे इतले कितें घालता बाय मेसेज राव थंड घे पासिंग कितले रे 14 न्ही रे पासिंग आउट ऑफ 70 14 न्हू 14 24 रे 24 ना 14 आसतले सारखे म्हाका बी खबर ना 15 धर 246 कमॉन गाईस बेगीन लाईक करा आणि हांव वयता बेगीन प्लीज बेगीन करा आय गॉड ते पळय कितले लायक काडले पळय 2 लायक काडले आता घालतले कितें करता पळय नाटकां पळय कितें चल्ला पळय You can like, okay, all of you like it. Like the video. 250 likes. आम्ही या. Wasted time pass कर नका. सर हाऊ मच पासिंग सांगले मगो बाय तानिया के झाले सांगले मगो 15. सर तुमको शिगमा केन्ना रे खबर ना रे आता असतलो केन्ना तरी. सर त्यांची लाईफ केन्ना जातली फाल्याच्यान करया मरे. सर तुमगे शिगमो केन्ना सांगले रे बाबा आमगे शिगमो असा केन्ना ते खबर ना. रियल लेजंड आता शिकपाक स्टार्ट करतले सारखे बाबा. रियल लेजंड्स आर स्टार्टिंग राईट नाव. रियल लेजंड फेल्स ऑल्सो. ओके जर सारखे अभ्यास जावंक ना जाल्यार. सर सीएस स्ट्रीम जाय हे बाबा नाका रे सांगला मरे तुका. 250 झाले 255 लाईक्स झाले. बाय 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 बाय. आय एम गोईंग लिव्हिंग. हे कोण. हाय सर कॅन यू प्लीज सेंड मी केमिस्ट्री पीडीएफ विच यू डिड फॉर टुडेज क्लास. कोण रे. Okay, who wants the PDF, I can just share the link. आणि फाल्यां म्हाका सांगा तुम्ही सगळी जण सांगा म्हाका स्टोरी बिस्टोरीन मेन्शन करा. पेपर बरो गेलो जाल्यार स्टोरीन मेन्शन करा. कितें बी क्वेश्चन तुमकां येता बिता ते क्वेश्चन बी घालून मेन्शन करा. ओके की क्वेश्चन येयल्लो बरें जालें बी सगळें चिल करया. फुल ऑन फ्री शाउट आउट. आणि म्हाका मेसेज करा पेपर कसो गेलो की. ऑल ऑफ यू मेसेज मी हाऊ वॉज युअर पेपर टुमॉरो. ओके. Then we will discuss the paper also. So I have posted the link. Just check. You can get the notes. I will just go and upload the remaining ones of today's PDF. Yeah. सर आता माझे बायोमॉलिक्युल्स आणि एफ ब्लॉक उरला. कितें करूं फ्रॉम वेअर. आत्ता केले मरे आम्ही तेच कर मरे. कितें बाबा उलयता रे तुम्ही. बायोमॉलिक्युल्स वी डिड. हय हय नमाज पढ़ को जा आतिफ. अच्छा वेंगा. Pray to God. Pray to God and go to paper and write good paper. I am also praying for you all that your paper should be very boom. आणि बूम पेपर गेलो की चूम पेपर गेलो म्हाका पडलेलो ना म्हाका फाल्यां तुम्ही सांगा की पेपर कसो गेलो तो. ओके. पेपर पण बूमूच वतलो. सर ऑर्गॅनिक सांग मरे मोस्ट. ऑलरेडी टोल्ड part 2 of the live video. It is uploaded. Go and check. God doesn't support everyone. God supports everyone. Depends on how you want to be supported. Okay, don't worry. चढ मनार घेऊ नका. केन्ना वयर सकल असतात लायफान. Yes. So I am ending the live. Thank you so much for attending and all the best for your tomorrow's paper. याद दिन फाल्यां म्हाका धाडा. मेसेज बिसेज करा म्हाका पेपर कसो गेला तो. चिल करया. ओके. बाय गाइस. बाय बाय. टेक केअर. बाय. सर 12th पास जावन कितें करता. चिल कर रे. 12th पास जावन चिल मरे. मागीर सांगता कितें करपाचें. येस पार्टी शुअर. गिव मी पार्टी. वाळपे यात तुम्ही सगळी जाण फाल्यां. ओके फाल्यां सगळी जाण वाळपे यात आणि पार्टी करया. बाय बाय.